कानून को सर की जूम की मीटिंग भेज दी, अभी यूट्यूब
हाँ,
नहीं भेजा।
ठीक है ना, उनको वो मिल
यूट्यूब में
जाए।
अभी फिर अभी कर रही हूँ।
उनको भी बोलना पड़ेगा, जुड़ के देख लो एक बार। अब
हाँ,
15 मिनट ही तो बचा है, मैं
क्योंकि
बोलूँ क्या
नायक
फोन
सर
पर?
वहां से जुड़ेंगे, बोलेंगे सर
कहाँ
कानून
से?
जूम की मीटिंग भेज दी, यूट्यूब नहीं।
नायक सर कहाँ से जुड़ेंगे?
अभी कर रही हूँ, उनको भी बोलना पड़ेगा, जुड़ के देख लो एक बार।
पल्लवी, तुम्हारे चेहरे पे लाइट डालो।
नायक सर वहां
तुम
से
लाइट के
जुड़ेंगे,
अगेंस्ट
बोलेंगे
बैठी हो।
कहाँ से।
लाइट पीछे है कि लाइट सामने है? नायक सर कहाँ से जुड़ेंगे?
एक मिनट में
लाइट
से।
बंद कर दियो, लाइट डालो तुम्हारे ऊपर।
पल्लवी तुम्हारे चेहरे पे
हाँ, अब ठीक। हम्म। कोई और चौथा जुड़ा है अपने तीन के अलावा?
अच्छा।
हाँ, अपन तीन तो है, दिख रहे हैं, चार पार्टिसिपेंट्स दिख रहे हैं मुझको। पर उसने अपना वीडियो ऑन नहीं किया होगा, हो सकता है सुनीता जुड़ी हो या फिर अपने डिपार्टमेंट से कोई हो।
मैं चैट पे डाल रही हूँ, जरा इसको कॉपी करो।
चैट पे क्या डाल रहे हो?
यूट्यूब की लिंक
अच्छा।
है ना, इसको कॉपी करके मुझे भेजो जरा।
इसको, ये है जूम जुलो, नहीं ये तो, ये,
अभी चैट पे डाला ना मैंने,
हाँ,
चैट पे देखो।
देखती हूँ। हाँ, इसको क्या करूँ?
कॉपी करो और मेरे को भेजो।
कॉपी लिंक और तुमको व्हाट्सएप कर दूँ?
व्हाट्सएप कर दो। और फिर ओपन करके देखो कि चल रहा है कि नहीं,
तुमको भेजती हूँ पहले तो।
क्योंकि मेरे इसमें चल रहा
तो तेरे को लिंक भेजने का फिर क्या मतलब है?
है। नहीं, मैं बाकी लोग को पेस्ट करूंगी।
अच्छा।
मैं यहाँ से व्हाट्सएप नहीं खोल पा
हाँ, मैंने तुमको सेंड किया और यहीं से मैं यूट्यूब खोल के देख लूँ क्या?
खोल के देख लो। हाँ,
नहीं, मैं फोन
साउंड
फोन पे,
बंद कर देना उसका।
हाँ नहीं, फोन पे जुड़ती हूँ उस पे, इसी पे नहीं।
हाँ।
हाँ, जुड़ तो गया, तुम तो दिख रहे हो मेरे को
दिख रहा है
हाँ,
ना।
यूट्यूब पे अपन दोनों दिख।
थोड़ा स्लो आएगा, पीछे आएगा।
हाँ, उससे कोई दिक्कत नहीं है,
हाँ तो
वो
बस।
तो अपन बंद कर देंगे, मतलब
हाँ,
जुड़, लिंक
हाँ
है,
तुम
जुड़ रहे हैं,
हाँ।
तुम और मैं जुड़ गए।
हाँ तो मेरे को भेज दो।
भेज दी हूँ मैं तेरे को।
हाँ ठीक, मैं भेज
भेज दी हूँ, व्हाट्सएप उसी से जोड़ी हूँ मैं अपना।
हाँ।
ठीक है।
हाँ, मैं अब भेज देती हूँ।
तो
हम्म।
कानून को सर को फोन करूँ क्या?
हाँ,
करती हूँ, ठीक है। मैं बीच में क्लास लेके आ जाऊंगी, फिर जुड़ जाऊंगी आज। उठा तो नहीं रहे।
स्क्रीन शेयर हो रही है क्या?
हाँ हाँ, हो रही। थोड़ा छोटा करेगी क्या, पूरी नहीं हो रही?
वही तो मेरे से नहीं हो रहा है।
अच्छा, कोई बात नहीं। सर अभी उठा नहीं रहे हैं, समझ गए होंगे। बस उनको जुड़ जाए बस अपने साथ, वो प्रॉपर स्क्रीन शेयर हो रही कि नहीं हो रही दिख जाए।
हम्म। मेरे से हो नहीं रहा, रुक जाएगा
वो
मतलब।
ना वहाँ कहीं साइज का
हाँ
होगा,
हाँ
देख, प्लस
हाँ हाँ।
माइनस होगा, वो माइनस कर, हाँ।
आप दिख रहे हैं।
और माइनस कर, और कर, और करते जा, और करते जा। अब हाँ हाँ, अब दोनों दिख रहा है, वैसे एक भी दिखाएगी तो भी चलेगा, बड़ा बड़ा कर दे तो। हाँ बस बस, ठीक है, अब सब दिख रहा है, जितना उतना तो दिख ही रहा है।
अच्छा।
ऊपर का ही दिख जाए भले,
हम्म।
अपन ना दिखे, हाँ ये भी दिखेगा तो चले, थोड़ा सा एक प्लस कर सकती है। ठीक है। आज के स्पीकर दिख रहे हैं तीनों भी,
हम्म।
चारों भी। ठीक है, अब इन लोग के जुड़ने के ऊपर है।
सर क्या बोल रहे हैं?
सर फोन नहीं उठा।
मैं व्हाट्सएप कर देती हूँ।
हाँ करते कि आप एक बार ट्राई कर लीजिए, व्हाट्सएप अपन वो कर। चाय वगैरह बचे हैं क्या? हाँ, देर हो जाएगी, टाइम दे, फ्लास्क में डाल देंगे। वैसे मैं ना गाड़ी में बैठ के उससे जुड़ जाऊंगी, फोन से तुरंत। आज पहले भी तुमको कंट्रोल करना है।
हाँ, कंडक्ट करना भी कर।
हाँ, पहले भी करें। नायक सर से बात हुई कि नहीं आज?
हाँ हाँ
हाँ हो गई ना। और इनको डाल दी सुरेंद्र सर को, घास कट।
हाँ,
हाँ।
उनका आ भी गया, वो भी करके।
अच्छा चलो ठीक है, वो तो बहुत ही
तो
अच्छा
ओके
है।
करके कल ही आ गया था। मैं कल ही शाम को इन लोगों को जूम मीटिंग, यूट्यूब नहीं
हाँ
डाला मैंने।
हाँ ठीक है ना, इन लोग को अपने को जूम ही देना है, इनको क्या करना
सर का तो आ गया था। ओके
है।
कर।
ठीक है, बस तीनों और शर्मा सर लोग का भी आ ही गया होगा, ओके, उनको भी भेज दिए ना।
उनको भेज दी, उनको मेल कर दी।
ठीक
फोन कर दूं क्या? नहीं,
है,
वो
नहीं भेज
ये
दिए
वो
तो ठीक
अपने
है।
टाइम पे जुड़ेंगे, 11 बजे से है ना, इसलिए वो नहीं जुड़े।
हाँ हाँ, वो अपना समय पे जुड़ जाएंगे। ठीक है। आज तो लगता है क्या लेट हो जाएंगे क्या, 10 तो बजने आ गई।
सर को तो मैं लिख दी, सर प्लीज ज्वाइन करके।
हम्म, जुड़े लगता, कोई जुड़ा।
मैम हम बस 2 मिनट में आ रहे हैं।
हाँ हाँ, कोई प्रॉब्लम नहीं।
ओके मैम।
हम्म,
This is the humane. I took my hand up, but nearby. It tells me everything might be around me, where I am at the same time. I can also use it to ask questions like, when is the next eclipse? Where's the best place to see it?
This is an AI browsing the web or grabbing knowledge from all over the internet.
The next total solar eclipse will occur on April 8th, 2024. The best places to see it are Exmouth, Australia, and Eastern Europe.
I can use it for messaging, either by voice or laser. Tell Andrew I'll be there later tonight.
Your message to Andrew says I'll be there later tonight. Okay to send.
Make me sound very.
Your message to Andrew says I'll be there later tonight. Can't wait. Okay to send.
Yes.
One of the things that I like most about messaging is getting caught up. My AI summarizes what's important, so I don't have to go back and read every message.
Catch me up.
सर देख लिए हैं, आप जुड़ेंगे।
अच्छा बस ठीक है। खैर 11 पार्टिसिपेंट्स हो गए हैं, जुड़ गए, मतलब अपने डिपार्टमेंट के लोग जुड़ गए लग रहा है।
हम्म। कल ना रिकॉर्ड हुआ है, वहां से रिकॉर्डिंग यूट्यूब पे है पूरा।
हाँ
सर
यूट्यूब पे तो जुड़ गए,
गुड
सर जुड़
मॉर्निंग
गए।
सर।
गुड मॉर्निंग सर।
मॉर्निंग मैडम।
गुड मॉर्निंग सर।
गुड मॉर्निंग।
चलिए पल्लवी,
सर शेयर करके देख लेती हूँ। मैं स्टॉप करती हूँ।
सर सर एक बार
मैं
आप
स्टॉप कर रही हूँ।
हेलो
हाँ
हेलो,
यस
आप
सर,
माय वॉइस इज क्लियर?
यस सर। सर थोड़ा सा और पास से बोले। हाँ, या तो साउंड इंक्रीज कर लो। हाँ, उतना मुझसे बोलो। ठीक है सर।
इज इट ओके? इज इट ओके नाउ? साउंड इज क्लियर?
हाँ, यस सर।
सर
सर स्क्रीन शेयर करके देखना चाहेंगे क्या एक बार?
कर लेता हूँ।
करके देख लीजिए, कुछ प्रॉब्लम आ रहा हो तो फिर, नहीं तो फिर अपन उसके बाद स्टार्ट कर देंगे। आप
अभी 3 मिनट है।
हाँ नहीं, शेयर करके देख लें
हाँ, देख लीजिए सर।
बस। हाँ हो रही है। ओके सर, ठीक है सर। आप अभी
हाँ सर, हो रहा है।
दिख रहा है सर
स्लाइड
अभी?
शुरू कर लेते हैं।
अभी उसको बंद कर दीजिए।
Good morning, everybody. Good morning.
गुड
गुड
मॉर्निंग सर।
मॉर्निंग सर, गुड मॉर्निंग।
गुड मॉर्निंग सर।
गुड मॉर्निंग एवरीबॉडी।
पल्लवी मैडम,
यस मैम।
आप हो ना?
हाँ मैम।
ओके, स्क्रीन पे दिख नहीं रहे हो?
हाँ
वीडियो ऑन कर लो।
हाँ, वीडियो
हाँ
ऑन।
फिर ठीक है। ओके ओके।
हम लोग एक फोटो सेशन, फोटो खींचते हैं।
जियो टैग फोटो कर लो।
जियो टैग करोगे? करो।
हाँ कर लीजिए। हो गया।
ओके।
10 बज गई है, अपन शुरू कर सकते हैं क्या?
यस। पल्लवी,
Namaskar.
वी कैन स्टार्ट नाउ।
हाँ।
Okay, ma'am. A very good morning to all. On behalf of organizing committee, I am privileged to welcome all the dignitaries and participants in the second day of 2 days international webinar on plankton biology. In today's session, there will be five guest lectures from very eminent speakers, followed by valedictory function. Today, the first lecture will be delivered by Dr. Vimal Kanungo on phytoplanktons in some ponds of Raipur city. To introduce Dr. Kanungo, I would like to invite Mr. Satish Ramtike, Assistant Professor, Department of Zoology. Satish, sir?
जी मैम, थैंक यू मैम। A very good morning to all of you present here. Our chief guest, Dr. Vimal Kumar Kanungo sir, other dignitaries, respected seniors, and all other participants present in the second international webinar on plankton biology. It gives me immense pleasure to introduce our guest speaker today, Dr. Kanungo sir. He is currently posted as Assistant Professor, Department of Botany, Government J. Yoganandan College, Raipur. He did his master's in botany with a gold medal from Pandit Ravi Shankar Shukla University, Raipur in 1982. He did his PhD in 1987 from Ravi Shankar University, Raipur. His area of interest is environmental biology. He has a teaching experience of more than 35 years and a research experience of more than 30 years. He has successfully guided 23 PhD scholars and currently guiding three scholars. He has chaired more than 20 seminars and conferences. He is a counselor for life sciences at IGNU. He has more than 60 national and international publications, has published more than 5 books, and he has a YouTube channel by the name of the Botany Class. The list is endless here, so I welcome Dr. Vimal Kanungo, sir. Sir,
Thank you, sir. Thank you for introducing me.
thank you, sir.
Good morning, ma'am.
Good
So
morning,
now
ma'am.
I am going to share my screen.
Yes,
Yes,
sir.
sir.
Is it visible?
Yes, sir. It is visible.
Thank you, Satish sir, for introducing me. And
Thank you, sir.
I am alumni of same college, government Nagarjuna Postgraduate College of Science, where I studied for 5 years. Then I started my PhD work from Science College. So it is a small piece of work which I am going to discuss here. And if I look the history of phytoplankton study in Chhattisgarh, it is way back in 1983 when my great teacher, Dr. M.L. Nayak, he has given me the idea to pursue PhD work, and we have started working on phytoplanktons of Raipur city. So we have analyzed more than 30 ponds of Raipur city in terms of physicochemical analysis and the phytoplankton diversity. And many of the phytoplanktons identification work, zooplankton, I am not going to speak, but he has identified many of them. Later in the day, he is a speaker, he will share a lot of findings. But I am going to discuss a very small piece of work which I conducted here in Raipur city. So my first slide is it demonstrates what is phytoplankton. So plankton term was coined in 1887 by Hansen, and if we see the literal meaning, it means which drifts are which drown in the water, which is found dwindling in the water. So they are the microscopic organism, single-celled photosynthetic organism found in water, belong to the group of algae, and they are found suspended in water. And mostly they are found in the pelagic zone, which is the large part of the pond or any water body where they are found distributed. And they are very important because they are the primary producer in aquatic ecosystem. So they are the primary producer in food chain. So they are very important for the study. Now, next slide, it is divided into phyto and zooplankton. As you know, all those planktons belong to the plant category. They are known as a phytoplankton, the animal category zooplankton. And they are very small, so they cannot be seen by unaided eye. And when they are found in higher concentration in water, it looks like a green. So many of the pond, we see that it looks like a green in color. I will show you some of the ponds. So they are green in color due to presence of chlorophyll, and basically they are the autotrophs, photosynthetic organism. They can synthesize their own food. Now question arises, why are they important? Why their study is so important? Why we are talking so much, and why the webinar is organized on this small organism? So the first important thing is that they generate half of the atmospheric oxygen, which plants they do in whole year. So almost half of the atmospheric oxygen is contributed by phytoplankton, and they form the food web. And for all the aquatic organism found in the ponds and all the water bodies, so food web, they are very much important part of the food web, because the food chain begins with these primary producers. Another important thing that they transform the inorganic carbon to organic carbon by photosynthesis, and they are very much important organism of carbon cycle. Phytoplankton also, they control climatic system. So climatic system is also regulated because they are contributing a very important gas in the atmosphere, that is oxygen. So they have some sort of act in regulating the climate, and they are important for biogeochemical cycling. The cycling of carbon is done by these phytoplanktons. These phytoplanktons, the cyanophyceal phytoplanktons and the photosynthetic bacteria, there are so many, they release a very specific type of vitamin and micronutrient, and they are very important for sustaining the life in water. Same time, some cyanophycean phytoplanktons, they releases the toxic material, which is very harmful to the life. So both the things are there, that some phytoplanktons, they are very useful, and they are releasing vitamins and micronutrients to sustain life in water. And the dense bloom, when the in a very hypereutrophic condition, when there is a huge growth of phytoplanktons, then there is a depletion of oxygen. The BOD value and the COD value increases, and it leads to the depletion of oxygen. And later we see that it is one of the important reason for fish death. Some species, they produces toxin. I told that it may cause illness or death. And harmful algal blooms, they make a significant economic loss in our aquaculture. A wide variety of cyanobacteria like Microcystis, Dolichospermum, which is earlier known as Anabina, Planktothrix, Microcystis. These are some bloom forming phytoplanktons which are toxic in nature. These are the important groups which we have investigated: cyanophycean group, cyanobacteria, that is chlorophyceae, cryptomonads, dinoflagellates, and some diatoms. But if we see in the water, there is a predominance of diatoms and dinoflagellates in phytoplanktons. There is some ecological importance of phytoplanktons, like their involvement in oxygen production. They are the vital link in food chain that I told you, and they are useful in aquaculture and mariculture. And the important thing that since 1940, phytoplankton have decreased by 40%. And this data I have taken from the net, and it is rate of decrease is 1% per year. So it is quite alarming. And the reason thought to be that is the ocean warming. So ocean warming, which is one of the important region for phytoplankton loss, their diversity loss in the freshwater as well as the marine water. There are some human impact in these days. If we talk about the ponds in the city, that they are having lot of input of domestic wastewater and other waste, and lot of human activities, wallowing of animals, washing of utensil, washing of clothes, so many human activities. They are contributing the nitrogen and phosphorus to the water. So it is important for, it is causing the eutrophication, that is the enrichment of water with nitrogen and phosphorus. So gradually the ponds, they are moving towards the eutrophication, or eutrophication to hyper-eutrophication due to this input. And then there is this is the reason for formation of algal bloom, and a lot of cyanophycean algae, they grow due to this eutrophicated condition and responsible for lowering the dissolved oxygen in the bottom water. And it causes lot of harm or mortality of fish and invertebrates. And one important thing that I read in forensic science nowadays, phytoplanktons, they are used. The site of drowning of water in mysterious death, in any site where the drowning or mysterious death occur in the water due to drowning, that site can be determined by taking the phytoplankton. This is a new thing that they are exploring. The forensic scientists, they are exploring this important aspect of the phytoplankton. This is the carbon cycle. We see that they are taking carbon from atmosphere and they fix it and form a organic food, and later on after completing the life cycle, it is decomposed by various organisms and they contribute. Entire carbon cycle is the driven force is that phytoplankton in the water. Then there are two important things which recently I have taken. This I have taken from the net. Here, a very alarming situation has been given that between late 1997 to mid 2008, satellite observed that the warmer than average temperature, this red line which is showing the temperature, so there is a gradual increase in the temperature since 2000 to 2005. So this has been seen through satellite imageries that there is a blue line which is showing that there is a decrease in the chlorophyll concentration. So this is the graph. This is the reference is here, Barenfield et al. 2009. So this is the condition. The increasing temperature due to greenhouse effect may lead to the problem to the phytoplankton diversity in aquatic system. And same with the carbon dioxide concentration, it is gradually growing, and this blue line which we are seeing, that gradual increase in the carbon dioxide concentration, and it is speculation is there that in next century there may be the great decrease in the phytoplankton population, mostly the diatoms, their growth will be declined. So these are the two studies. This is of both 2005. This graph shows the alarming situation may occur in near future. Due to these facts, the phytoplankton or the plankton study is so important, and it is very essential to know their diversity, their abundance in the water, because there are so many conditions which correlate their abundance. Now I will concentrate on my small piece of work which I have conducted in Raipur city under the guidance of my teacher, Dr. M.L. Nayak, who has suggested me this kind of work and also helped me in identification of many of the phytoplankton. So let us see this is the situation of Raipur. You know, this is the coordinates you can see, and the key important thing is that there are 50 ponds, more than 50 ponds in and around the city of 0.05 to 35 hectares. This is the key thing, that lot of ponds are there in the city, and then due to urbanization we are losing many of the ponds. And second important thing what we see in the city, that the center part of the city is a upland, and the periphery of the city is a bit downward. So the ponds located in the downward side at the periphery of the city, they are receiving the city waste, which we call it as a sewage, and that is one of the thing which is very serious, that all these ponds, majority of the ponds in the city, they are receiving domestic wastewater. And if we see the human activities are very common in all the ponds we have seen in the city, that cattle bathing, washing of utensil, washing of clothes, it is very common in the city. Now I have selected three large ponds of the city. Number one is Maharaj Band. This pond is 14.2 hectares in size, and the area around is red soil, and many of the time we see there is a huge growth of Eichhornia crassipes, and it is removed by the local people. So growth of macrophytes, it is common in this pond, and it receives city waste from the northern side, and human activities, as I told you, it is very common. So, but one important thing what I saw in my work, that the water level, it remains constant throughout the year, because it receives water, domestic wastewater, as well as water from seepage. The second pond is Budha Pond. It is another it is biggest pond of the Raipur city, which is spread over from 34 hectares of the area, and it has got a cemented boundary. The larger part is covered by cemented boundary, and very small part is land. But the area, it also receives domestic wastewater and water hyacinth, the Eichhornia crassipes. Its growth is very common. Many a time it is removed. So water level here also, it remains constant throughout the year. So these are the two ponds which we have selected. It is domestic waste receiving ponds. So idea was that why not to compare the phytoplankton and the physicochemical characteristics of these ponds which are receiving domestic waste, as well as the pond which is having earthen boundary, where human activities are there, but the domestic wastewater, it is non-domestic wastewater receiving ponds. So another pond that we have selected for our study, that is Domer Pond, that is in our university area. It is a man-made pond, has a earthen boundary, and the pond is of 6 hectare in size, but it has no entry of city waste. And growth of macrophyte is totally absent, but the human activity is quite common, and depth was 1 meter. So this Dover pond we have selected as a non-receiving domestic wastewater pond. Now come to the methodology which we have adopted, that is to know the water quality of these ponds. We have analyzed the physicochemical characteristics of the water, and it is all done by using the methods prescribed in AFA WPCF, standard methods for examination of water and wastewater. That is the publication of our WPCF American publication. This we have used for analyzing the pond water. Then phytoplankton collection was done by 3 of the method, by plankton net method, by concentration through the centrifugation, by taking the water sample and centrifuged it in a centrifuge machine, and concentrated a part of this phytoplankton and supernatant, it is being collected, and then the concentration by natural settling. In the beaker, we have kept the pond water, and it is allowed for a few hours to settle down naturally. And these 3 modes in which collected phytoplanktons, they were collected and used, identified under the microscope. And we have calculated similarity index by following the Sorensen's formula, and indices of phytoplankton by Nigard's formula. These are the formula, it is given in the book. The similarity index is equal to 2C by A plus B. A is a number of species in pond A, B is the number of species in pond B, and C is the number of species common to pond A and B. Then the phytoplankton indices, Nigard, it was calculated by Mixophycean index or Cyanophycean index, M by D. It is the number of species of Mixophycean member divided by the number of individual species of Dasmids. Similarly, the Chlorophycean index was calculated by using the formula of the individual members, the number of species of Chlorococcalis divided by the number of Dasmids. Similarly, Euglenophycean index, it was calculated by the number of species of Mixophyceae, Chlorococcalis, and diatoms divided by Dasmids. And mixed index was also calculated by dividing Dasmids and the number of Mixophycean myxophyceae and chlorophyceae and euglenophyceae. These are the two aspects which we have studied in sample collected, that is physicochemical characteristics of pond water and seasonal abundance of phytoplankton. These are the parameters studied. Here you can see the temperature, second is transparency. In terms of transparency, the sewage receiving pond has got greater transparency, and then turbidity, the Buddha tank water was highly turbid. The range we see here, and the conductivity similarly, these are conductivity value, phenolphthalein alkalinity, methyl orange alkalinity, it is higher for Maharaj Band pond, total alkalinity. Then comes the carbonate and bicarbonate alkalinity. Free carbon dioxide was found totally nil in all the ponds. Total carbon dioxide was calculated by using the formula. It was higher in Maharaj Band. Then the Buddha tank and followed by the Dumar pond. pH was determined. Dissolved oxygen, the value was comparatively higher in Dumar pond, which is not receiving domestic waste. Here the oxygen saturation, it is determined BOD and COD value. Contrastingly, the BOD COD value was determined bit higher after doing so many tests, and contrastingly this we have obtained. This is possibly the discharge of fecal material by animals in water directly. So that has might have increased the BOD and COD value. Then the voice is clear, madam? Is it okay? Voice is clear?
Yes, sir. Yes,
Okay.
sir. Voice is clear.
Okay. So total RDS, calcium RDS and calcium, they recorded higher value for Maharaj Band pond, which is a sewage receiving pond, followed by Buddha tank and the Dumar pond. So magnesium value, nitrite, nitrate and phosphate value. So we have seen the Maharaj Band and the Buddha tank, which are the sewage receiving tank, they have greater amount of nitrogen as a nitrite and nitrate form, and phosphate in total ortho acid hydrolyzable, total phosphate and the organic phosphate form. But contrastingly in Dumar pond, we observed as a little higher acid hydrolyzable phosphate. This is the second part, phytoplankton study, that under microscope these phytoplanktons looks like. This is one photograph. These are the zooplanktons which we can see under the microscope. Now come to my phytoplanktons recording. So phytoplanktons of chlorophyceae, which the largest group we recorded in our study. So Maharaj Band recorded 23 genera, 57 species and 70 varieties and forms. Similarly, the Buddha pond 22, 52 and 63 forms. Comparatively, if see the Dumar pond, which recorded little lower number of phytoplankton as their growth is less, as the pond is not receiving the domestic waste. These are some of the commonly found species recorded throughout the year, like Actina, Strum, Hantzai, Enkystrodesmus, Botryococcus, Crucigenia, Synadesmus, Tetrahedron, Vestella. And these are the dominating species of Buddha tank. And Dumar tank, we have observed Botryococcus, Synadesmus species, and Tetrahedron and Scroderia. These are the dominating species we have recorded belong to chlorophyceae in these three ponds. Now, the number of species, number of genera which we have recorded for in Maharaj Band, Actinastrum one is one species. These numbers are denoting the number of species. This genera, Enkystrodesmus 2 species, Batriococcus 1, Chlorella 1, Chlorococcus, Cordatella, Celestrum, Cornestrum, Crucigenia, Dictylosphaerium, Elecatothrix, Kircherinella, Ucistis, and Aurococcus, Pediastrum, Quadrigula. But the largest number of species and forms were recorded. That is the Synodesmus. There are 26 species and forms, and Tetrahedron, it is 11, and Pediastrum 6 species. So some of the phytoplanktons, there large number of species were recorded, and their seasonal abundance was seen. Monthly abundance was recorded, but these are the these are the commonly found species which are found throughout the work in all the months of study. Now come to the Cyanophycean member. 19 genera, 48 species and 49 varieties were recorded in Maharajband. Then 18 genera, 42 and 43 varieties from Buddha Tank. Both are similar. Dummer Tank, it has comparatively less number of genera, 14 genera, 33 species and 35 forms. And these are the commonly found species which I have displayed here: Anabenopsis raciborski, Oscillatoria limnatica, Raphidiopsis, Anabina femijomenidis, Anabina flossequi, Arthospira platensis, variety non-constricta, and Lingbaya microcystis aeruginosa. And similarly for Buddha Tank, Anabenopsis raciborski, Oscillatoria limnatica, Raphidiopsis, Anabenopsis femijomenidis, Arthospira, and Lingbaya microcystis oscillatoria. So if you look at to this, you will find that comparatively the phytoplanktons recorded in these two silage receiving ponds, they are similar and found almost dominating throughout the year of study. Almost in every recording in monthly interval, we have observed these species. And then come to Dummer Tank, some difference in the species, that is Merismopedia, Spirulina species are 3 species of Spirulina, and Dactylococopsis raphidiodis. So there is some difference in the species in Dummer Tank. These are the number of species. Anabenopsis, Anabina recorded 7, and then come to Phenocapsa recorded 5. Then there is 8 species of Oscillatoria, and other have recorded 1, 2, 3. Microcystis recorded 4 species. So Cyanophyceae recorded a large number of genera and species in these ponds. Now come to the Euglenophyceae. The Euglenophyceae members are less in these ponds. 4 genera only recorded, 20 species, 23 varieties. 2 important genera which was recorded throughout the year, that is Euglena and Ficus. And Buddha Tank, it is 4 genera, 23 species, 25 varieties. It is recorded, and the genera are same. Only in Dummer Tank we have recorded 1 species, that is Trachelomonas volvocina. That is a different genera we recorded in the Dummer Tank. However, the number and genera and species of Euglenophyceae, they are almost same. But if we see the Desmids, the only species recorded in our study, that is Clostridium acutum in Maharajband. In Buddha Tank, that is the Clostridium acutum. It is in all the 3 ponds, the species recorded Desmids, and they are very scarce in number. These are the respective number: 9 species of Euglena, 10 species of Ficus, and 9 species of Trachelomonas were recorded. And entire monthly or seasonal abundance, it has been recorded. I am unable to display due to large size, did not get that much time to incorporate it. So entire data of seasonal abundance is available with me. Only I am showing some of the genera and number of species, how their number which is recorded. Other species of then the Desmids, Euastrum and Staurostrum. Clostridium is the dominating genera, recorded 3 species in all the 3 ponds. But sometimes the species of Euastrum, 2 species, and Staurostrum, 1 species was also recorded. These are the phytoplanktons of the diatom species. The diatoms, their number is 10 genera, 13 species, 14 varieties in Maharajban, and similarly the Buddha Pond 6 genera, 9 species and 10 varieties. But contrastingly, in Dumar Pond, which is a Sulej non-receiving pond, recorded less number of genera and species. Cyclotella meningiana, Melocera granulata variety, Entulesima and Nigesia, they are the three important pollution tolerating species found in the ponds. So they were almost present in all the three ponds. These are the species: Cyclotella, 3 species, then the Melocera, Navicula, Nigesia, Pinnularia, Synedra, Fragillaria, all these species were recorded. Now the phytoplankton indices. If we see the phytoplankton indices in terms of their phytoplankton cyanophycean value, if we see the Maharajban 16.33 and Buddha tank 14.33, both are close by, and the values are quite lower for Dummer tank. Similarly, for chlorophycean, euglenophycean, and compound phytoplankton indices are quite close by of Maharajband and Buddha tank, but contrastingly low for the Dummer tank. Similarity indices, if you see that when the similarity was observed between P1, P2, that is the Maharajband and Buddha pond, pond P1 and P3, Maharajband and Dummer pond, and P2, P3, that is the Buddha pond and Dummer pond, we are seeing the similarity data for cyanophyceae comparatively little higher in pond P1 and P2, that is the Maharajban and the Buddha pond. And similarly, the chlorophyceae, euglenophyceae, diatomaceae, desmidaceae, their similarity indices were determined where we have registered that the pond P1 and P2, that is the Dudhadhari pond and Maharajban, they have great similarity in terms of phytoplankton. Now, some pollution tolerating species, Palmer identified Nigesia palea and Cyclotella meningia and Melocera granulata. They are the pollution tolerating species, and we have also recorded in our present study. Similarly, the desmids, why the lower number of desmids was recorded in present study, the most probably reason which we have observed, that is the less amount of calcium in this these pond water, so that reduced the number of desmids, and it is the references Pearsall and Hutchinson. And these are some of the species I have taken from the net. These are the species, they are the pollution indicating species: Enkystrodesmus, Clostridium, Synedesmus, Pandorina, Eudorina, Pediastrum, Navicula, Nigesia, Cinderella, Melocera, and Gomphoneema, Nigesia, Trachelomonas, Fecus, Euglena, Liposinclis, Nigesia. This list has been given by Ajayan and Ajit Kumar in their paper published in 2018. These are the pollution indicator species, and very important thing that all these species are present in all the 3 ponds of Raipur city. So they indicate the pollution. And later we have correlated the data of physicochemical characteristics with the ponds phytoplankton's dominance or phytoplankton's abundance. So we have observed that there is mostly negative correlation of coefficient was determined between the species and the various parameters, physicochemical parameters. But mostly the R value was calculated are insignificant in the study, and the transparency and the total hardness value, calcium hardness value, these are some of the parameters registered positive correlation with the members of only chlorococalus, and so with some cyanophycean forms. But in entire correlation study, on the basis of that, we have concluded that physicochemical characters alone, single physicochemical character is alone not responsible for phytoplankton's abundance, are a strong determinant for any particular species of phytoplankton. So there is a combined impact of many of the parameters which determines the existence of a particular species in pond water. That is required to be, more studies are required to do so, to identify so why a particular species is inhabiting a particular area, and what is their correlation with the physicochemical characters. So lot more investigation are required for establishing these facts. Ultimately, the conclusion of my work, in brief, I want to tell you that all the three investigated ponds, they are progressing toward eutrophication, or you can say they are eutrophicated plants, and they are moving toward hyper eutrophication. That it is suggested by our physicochemical analysis data. And we have compared our data with the data of whole country and abroad. So almost we see that for eutrophicated water, the similar kind of physicochemical values are received by various workers. And the phytoplankton flora has dissimilarity we have seen in domestic, west receiving and non-receiving ponds. So there is a clear-cut difference in existence of few species which are entirely not found in the domestic wastewater non-receiving ponds as compared to the receiving ponds. All the ponds we have seen in our study, they are dominated by the members of Chlorococcalis. It is a group of Chlorophyceae and the Cyanophyceae. These two are the dominating group in all the three ponds. Diatoms and desmids were very low in types and their relative dominance. I told you the reason that the calcium is in some of the references we have seen that calcium is lower calcium inhibits the growth of desmids, and we have compared our data with other workers' data regarding the identification of pollution tolerating species. So I have shown all the species, all the genera we have recorded. They are, most of them, they have been indicating the pollution in the pond. And these are some of the drying through micrometry in microscope. We have drawn some of the, now the facility of microphotograph is also available. So microphotographs are also taken, but their measurement we have done with the help of micrometry in microscope. So these are drawings of these phytoplanktons, Synadespus species, and you can see how the variation is existing. So in this way, we see a lot of drawings it has been made after identification. In identification, we have used some of the important manuals. There is a book of Desikachari in Cyanophyceae, and some Volvocalis book which is available in Science College Library itself, which was used for identification. And nowadays, there are so many manuals, they are present for identification of these phytoplanktons. So these are the Oscillatoria species. These are the Ficus species. So these are some of the drawings we have made on the basis of measurement, respective measurement. So in this way, and in all these drawings and photograph which we have drawn, are the size we have determined. The Dr. M.L. Nayak, my teacher, he has helped me a lot in making all these things, and he himself done many of the drawings too, and helped me in identifying many of the phytoplanktons. So I also thank my teacher that it was his vision that he has suggested me such a nice piece of work, and also helped me in doing that. In later today, he will speak in some other aspects of phytoplankton. So this is all about my small piece of work, and I am very thankful to organizer that they have given me a half an hour time to share my small piece of work which I have conducted in Raipur city. Thank you very much.
Thank you very much, sir.
Thank you, sir, for such a informative lecture. Now the session is open for the discussion, and participants can unmute themselves to ask the question, if any.
Sir, can I ask?
Yes, yes,
Sir,
madam, you can ask.
आपने तीनों तालाब में किया है तो कुछ डिफरेंसेस थे क्या?
Of course, I have shown you in my regarding phytoplankton, contrastingly difference in the physico-chemical parameter which I have displayed, that two of the sewage receiving pond having higher amount of nitrogen and phosphorus as compared to the non-receiving pond. And these eutrophic condition, that is enrichment of nitrogen and phosphorus, they boost the growth of phytoplankton. So many a time the huge growth it is been observed in the Maharaj Pond and Buddha Pond as compared to the Dummer Pond, which is receiving less amount of organic nutrients.
Sir, is there any difference in the fish culture pond and the non-fish culture pond? The phytoplankton's diversity is different in fish culture pond and the non-fish culture pond?
We have compared many of the studies conducted throughout the country in fish culture and non-fish culture pond. There are some difference. I don't say that no difference is there, but in large part, if we see, many of the species are common because their growth is boosted by the nutrients present in the water and the physico-chemical condition available in the water. As I told you that many of the conditions that determine the existence of a particular phytoplankton.
Thank you, sir.
It's okay. Thank you.
मैं कुछ पूछ सकती हूँ?
पूछिए
Yes, sir.
मैडम,
Yes, ma'am.
जरूर
Yes, ma'am.
पूछिए.
Thank you, thank you. I just wanted to know, I liked your talk very much and it was very informative with a lot of information there about the different algal groups and cyanobacterial groups. I just wanted to know whether the water that enters these ponds is partially treated or direct waste.
It is direct waste, madam. Actually, it comes as a seepage from the lot of population growth. Due to population growth, lot of colonies and lot of people, they reside by side of pond. So their wastewater gradually it comes, and sometimes in ponds of outskirt, due to downward side, due to overflow, many a time this wastewater comes into the pond, and in two of the ponds we have seen that domestic waste is directly entering, and this is the reason that there is no change in the water level throughout the year as compared to the Dummer pond.
Okay. How much water was to feed?
Yes, madam.
आपने पानी को फिल्टर किया था, डायरेक्टली ले लिया था?
Yes, yes. So I told you, madam, in all the three way, plankton net से filter करके भी लिया है, फिर centrifuge भी हमने किया है. तो for so many times water is centrifuged in centrifuge machine. Every time whatever content was coming, we are collecting it in a small bottle and preserving it. And directly from allowing water in a beaker for natural settling, through this also we have seen. So through and directly also pond water was also seen. So every possible way we have observed.
इसका size क्या था?
हाँ, madam.
Ma'am, your sound is not clear. Please.
Your sound is not
closer.
clear, madam.
Please come closer.
Yes. Can you hear me now?
It's okay.
Now
Yes,
it
yes.
is clear.
Yeah, now
Now
it's
it is clear.
अच्छा, I just wanted to know what was the size of the plankton net mesh size क्या था?
Exactly, it is a normal size which is available in the market. What?
अच्छा, ठीक है. और finally, the presence of Botryococcus is very interesting. आप लोग ने culture नहीं किया Botryococcus को?
No, madam. We haven't done it.
क्योंकि Botryococcus बहुत valuable algae है और उसमें से जो ऑयल निकलता है ना, वो ऑयल बहुत वैल्यूबल है यहाँ, मतलब वो ग्रीन और पेट्रोलियम को सब्स्टिट्यूट करने के लिए.
जी जी मैडम.
तो अगर आपके पास इतना अबंडेंट है और इतने नजदीक है, तो आप जरूर कोशिश कीजिए उसको कल्चर करने के लिए, और लार्ज स्केल कल्चर करेंगे बोट्राइकॉकस को तो
जी
बहुत
मैडम,
बहुत फायदा हो सकता है।
जी जी मैडम,
हाँ
जरूर कोशिश करेंगे मैडम। जो मेरे दूसरे स्कॉलर्स हैं उनके साथ मिलकर,
हाँ,
और मैं जरूर ये कोशिश करूंगा मैडम।
थैंक यू, बहुत अच्छा, बहुत अच्छी
थैंक यू मैडम।
मतलब इंफॉर्मेशन हमें मिला और मैं बहुत कुछ सीखी। एक मिनट, डॉक्टर शर्मा के पास एक मिनट।
I have a very these days.
Sir, your voice is not clear,
Oh,
sir.
yeah.
Yes,
This
sir.
is very interesting talk because these days people are not.
Sir, voice is not clear, sir. Voice is
Sir,
not clear.
please
I'm
come
unable
closer.
to hear you.
Okay, now can you hear me?
Yes,
Yes.
yes.
Okay, now this is an interesting study because generally seasonal studies are rare and one-time collections are very common because they are not interested to study throughout the year. And your data, probably you must have done multivariate analysis of the phytoplankton abundance and diversity to know the impact of combined effects of different physicochemical variables. This is interesting. Second is, did you publish this information in the form of an article?
Uh, some of the research paper has been published, sir, and few we are preparing to publish. Just I want to determine some diversity indices. After doing that, we shall publish it.
There are diatom specific indices. You can use them. They indicate water quality in a better way. But work is very interesting. Thank you very much.
Thank you, sir. Thank you.
Thank you.
Any other question?
I have one question.
Okay. You can ask. Akanksha? Akanksha, unmute yourself.
Akansha, unmute yourself.
That about 50% of oxygen
Yeah.
on Earth is contributed by phytoplankton.
Please come closer and say loudly.
Akanksha, your voice is not clear. Come closer to the mic and then speak.
I am audible.
Yeah,
Yes,
yeah.
now you're audible.
Sir, I heard that about 50% of oxygen on Earth is contributed by this phytoplankton. Is it right?
It is given in the WHO's website, where I have collected this information, and it is taken from an authentic website. So possibly it is correct. And we know that the 90% water, Earth is covered by water, and a large number of phytoplanktons are available. So I think this information is correct.
Okay, sir. Thank you so much.
Thank you.
Any other question from the participants? I think there is no question. Now I would like to invite Mrs. Gunjan Ojha, Assistant Professor, Department of Geology, Government MPG College of Science, to give votes of thanks to Dr. Kanungo. Ojha?
Thank you, ma'am. Thank you, ma'am. Our sincere thanks to Dr. Kanungo for providing his invaluable time, knowledge, and work regarding planktons with a special reference to Raipur. He explained how satellite studies are showing that climate is changing continuously in Raipur and how this changing climate is affecting growth of these planktons. He also explained about many pollution indicator species present in all the three different ponds he has studied in Raipur. Not only that, he also explained physicochemical factors are responsible for growth of planktons after rather affected by many other factors. His work, I think, will definitely help in further researches. With this, I thank Sir once again. Thank you, sir, for your valuable information and time. Thank you, sir.
Thank you very much, madam. Thank you for giving me an opportunity to share my views in this webinar. Thank you
Sir,
to all
pleasure is
organizers.
ours.
Thank you to organizers.
Thank you,
Okay,
Ojha.
thank you. Thank you very much.
Thank you, Ojha ma'am. Thank you, Kanungo sir. Now the session will proceed by a guest lecture by Dr. Nandini Sharma, who will talk on design of simple predation experiments to improve survival of the larval fishes. To introduce Dr. Sharma, I would like to invite Dr. Sunita Patra ma'am, Assistant Professor, Department of Botany, Government and PG College of Science, Raipur. Patra ma'am.
पल्लवी मैं इंट्रोडक्शन दे रही हूँ, संगीता वाजपेयी.
Okay. Introduction of Dr. Sharma will be given by Dr. Sangeeta Bajpayee, who is Assistant Professor in Department of Botany, Government and PG College of Science, Raipur. Ma'am.
नमस्कार. सबसे पहले मैं इस इंटरनेशनल कॉन्फ्रेंस के सफल आयोजन हेतु डिपार्टमेंट ऑफ जूलॉजी को बधाई देती हूँ. मुझे बहुत खुशी है कि मुझे आज के सम्मानीय स्पीकर का परिचय देने का मौका दिया गया. It's my privilege to introduce respected Dr. Nandini Sharma ma'am. Dear friends, Dr. Nandini Sharma is a professor at Aquatic Zoology Laboratory Research and Postgraduate Division, National Autonomous University of Mexico. She did her PhD in 1995 from University of Delhi and has also done postdoctoral research in India and a training course in lake management at the University of Ghent, Belgium. Dr. Sharma started working at FES Iztakala in 1997. Her topics of interest are related to aquatic ecology, mainly cyanobacteria, zooplankton, and fish. A well-known researcher, she has published more than 275 research articles in highly reputed national and international scientific journals, including Nature. It is a renowned teacher and has imparted 40 courses in Mexico and India on zooplankton culture, aquaculture, ecotoxicology, and the art of scientific writing. She has worked as thesis director for 65 students at the bachelor's, master's, and doctoral level. She has attended more than 90 national and 50 international conferences. She is reviewer for more than 50 prestigious journals and is an editorial board of international journals. She has successfully completed many national and international projects. At present, she has the highest level of national recognition for investigator and the highest level of the productivity linked bonus offered by the UNAM. It is a matter of great pride and pleasure to have with us such a distinguished scholar. She will be speaking on the topic design of simple predation experiments to improve survival of the larval fish. Please, ma'am.
Thank you. And take a moment to share my screen. Can you hear me clearly?
Yeah, ma'am.
Thank you. No, it's on the web. Wait 1 minute. Let's be open first, no? This one. You want to move? From there you can. Can you hear me clearly?
Yes.
And
hello?
can you?
Yes, ma'am.
Oh, thank you. And can you see the screen?
Yes.
That's good. It's complete. It's okay, right? Can you hear me? Can you see me?
Yeah.
Okay. Thank you very much. Thank you very, very much for your kind introduction. And thank you very much for organizing this very interesting webinar. We are learning many things during this process, and it's wonderful. Today, I will be talking to you about the importance of fish larval behavior and the simple experiments that can be set up and conducted, which will yield a lot of information, which will be very useful for success in aquaculture. Aquaculture began about 4,000 years ago in China and in the 1700s in its present form in Germany. This is according to the FAO data by the United Nations. Now, aquaculture is a multidisciplinary science. It needs information from many fields, including engineering, veterinary science, biology, animal breeding and reproductive biology, and ethology, to name a few. So we are going to focus mostly on biology and ethology today. The most important thing that we need for successful fish culture is a sufficient supply of fish larvae, adequate conditions for their survival and growth, and knowledge about the age-related food requirements of these larvae, methods to have cost-effective production, and the impact on the environment. Now, there is a critical period during the life stage of these fish larvae when the mortality is very high. And this is particularly, it happens when there is a transition from endogenous to exogenous feeding. Therefore, during this stage, the density of zooplankton available to the fish larvae should be very high so that they will be able to capture, because their ability to capture larvae is not good when they are very, very young, a few hours or a few days old. Now you see the differences between freshwater and marine larvae. And freshwater larvae are normally a bit larger than marine larvae at hatching. The larval survivorship of marine larvae is very low. The dry weight is also low. They are pelagic spawners. Marine larvae are pelagic spawners. Freshwater larvae produce few large eggs, while marine larvae produce many, many small eggs. So the fecundity of freshwater fish is lower than that of marine fish normally. And there is also lower starvation mortality in freshwater larvae as compared to marine fish. Now, why study this feeding behavior? Feeding behavior helps us to understand what are the necessities of these fish larvae and how we can maximize their fitness. So for successful aquaculture, we must study the feeding behavior of larval fish, and this can be very easily done. I always suggest that if you are starting practice with a new species of fish, or if you would like to generate information about any important species which may be in danger of extinction or species which are important for human consumption, please invest 3 months in conducting these experiments. And with these 3 months of data, you will have a lot of experience and a lot of information to use so that you have very low fish mortality. First of all, you need to have good zooplankton culture, about which we already spoke yesterday. Now we look at the different aspects of fish behavior that we need to focus on. So the first thing is feeding cycles. The feeding cycle of a predatory organism needs or takes into account 4 or 5 steps: encounter of the prey, attack, capture, and ingestion. When the prey is attacked, the prey can also escape. When the prey is captured, the prey can also be rejected by the predator. So these aspects we must consider. The second set of information we get from prey preference experiments. If we conduct prey preference studies, and there are a huge number of different kinds of indices that can be used to calculate prey preferences, that also can be taken into consideration, and it's very important. You can do prey preference experiments by providing a proportion of different zooplankton and counting how much is left at the end of the study, or you can dissect the stomach contents. But for prey preference experiments, information and knowledge about taxonomy is very important. You need to know exactly the taxonomical details and how you will calculate these before you start these experiments. So, like I said, that the experiments itself, they last only 3 months, but you need to have all the basic data before that. Then you can conduct simple functional response experiments And these are also very useful. Now, the predation process as described by Green was, like I told you in the beginning, it takes into consideration the search. Once the prey is searched, the predator will encounter it. It will respond to the presence of the prey and then decide to attack it or not attack it. And once it is attacked, it will try to capture the prey. It is possible that the prey has sufficient defenses and may escape. And if the prey does not escape, it is ingested. So the capture success of the prey is very important to ensure that the predator is getting sufficient energy. And this is what can be easily studied. For instance, we studied this with a group of fish known as godidids in Mexico. Godidids are viviparous fish. They give birth to live young. And they are found in central Mexico. Their distribution is restricted to that part of the world. A very interesting group of fish and highly endangered. Many of them are highly endangered due to loss of habitat principally. Now, these fish are born with a very large gape size. And therefore, you can see that in the early days, they encounter, attack, capture, and feed on several rotifers. And they are not able to feed on Cladocera in the beginning, as you can see here. They ingest more rotifers, Brachionus caliciflorus. And their ingestion, or if you compare their ingestion of amongst Cladocera, they ingest more Moina rather than Daphnia. But with time, they shift from rotifers. You can see that the ingestion of rotifers is declining and ingestion of Cladocera is increasing. Now, what is the use of this simple study? This is how do you conduct this experiment? You conduct this experiment by putting the fish larvae pre-starved for 1 or 2 hours, and then you observe it under the microscope, the fish larvae. How many prey it encounters, attacks, captures, and feeds on in a period of 10 minutes. And you collect this data and do the analysis. But what is the importance of doing it? The importance is that you will not invest so much time and effort in producing rotifers after the 5th week. Because by the 5th week, they are not feeding so much on rotifers. So now you should shift their diet towards Cladocera because the species itself is telling you clearly that they feed better on Cladocera. So these kind of small experiments that can be done in a matter of months generate a lot of information and avoid our effort and cost in maintaining zooplankton. We have conducted several studies of this nature with different species of fish, for instance, with angelfish, also with blind fish. These are all fish. This blind fish, Astyanax fasciatus, is typically found in caves in Mexico, and also with Allotoca duhesi. This is also godidid. You can see how the prey capture decreases with the age of it feeds less on Caliciflorus as compared to Daphnias, increased feeding on Daphnia. Now, another point for which these type of studies are very useful is to evaluate or assess the impact or the stress that native fish taxa or native organisms receive, amphibians, and as compared to introduced species. So here what we did was we studied the effect of, studied the feeding of the endemic axolotl, Ambystoma mexicanum. It's an amphibian and it's native to Mexico. This is its type locality, Lake Xochimilco in Mexico City. And this is what we studied. And this species is a highly endangered species. It's absolutely on the brink of extinction. And what is the impact that it receives due to the presence of tilapia? Now, as all of you probably know, tilapia is an extremely voracious feeder and grows very fast, reproduces throughout the year in Mexico. And unfortunately, about 50 years ago, it occurred to the Mexicans to introduce tilapia into Lake Xochimilco. Now, tilapia, once it is introduced, it is practically impossible to get rid of it from this huge lake. The lake is very large. It is very shallow, only 1 meter, but covers an area of about 200 square kilometers. So it's a very, very big lake. Now, in this lake, they introduced tilapia, thinking it will be useful for the local population. But unfortunately, it is not, because the lake is also refilled with partially treated wastewater. Nevertheless, the Mexicans don't eat tilapia from this lake. Now, this tilapia grows and reaches such high densities that it not only feeds on the eggs of Ambystoma mexicanum, it also competes for the food. So this study clearly shows that the introduced species is competing excessively with the native species. You can see that from the second week onwards, tilapia is consuming a whole lot of moina over here, whereas the consumption of moina by the axolotl is only increasing up to the 6th week. So now it faces intense competitive pressure due to the presence of tilapia. Now, if you see these studies, we conducted these experiments using angelfish. Angelfish also have got a large gape size, and these angelfish do not feed so much on rotifers, brachiones, for instance. They prefer to eat moina neonates and adults from the first week onwards. On the other hand, mollies, which are also very common over here, they feed on rotifers during the early days, and later on they continue to feed on rotifers, but they also feed on other taxa, moinas, neonates, and adults. So it clearly shows that if you are trying to culture angelfish, there is absolutely no need to invest so much in the production of Brachiones caliciflorus. Now we conducted also these type of measurements. You can do these measurements, the relation between length and gape size of the fish, and you see that there is an increase over here. So the prey size is very important. You see that the gape size is increasing. So if the gape size is about 1500 micrometers over here, there is no point in feeding it on rotifers. The second reason, which I also spoke yesterday about autolytic proteolysis, this is also very important because you see in this wonderful image by Dabrowski in 1984 that with age, the fish is growing, and how the digestive tract from a straight tube is now developing into more coils to aid digestion. So in this phase, in which we are interested, the larval phase over here, you can see that the digestion will not be easy for balanced diets. That is why they need to have zooplankton, because zooplankton also aids in autolytic proteolysis and in its own digestion for the fish larvae. Therefore, fish larvae get a lot of nutrients from this zooplankton. Now, there are various factors which are associated with the food preference and capture success of fish larvae. And these factors are related to the predator or could be related to the prey. Now, related to the predator is the physiological state of the predator, that it should be healthy. Then its size, because there is a shift in its feeding niche with age. A hunger level. If the predator is very hungry, it will consume more prey. Then the prey density, it will lead to switching of prey if there is a shift in the density of dominant and less dominant taxa, and the vision and the reactive distance of the predator. Though factors related to the prey are prey density, morphology and behavior, vertical migration or the position of Scepholibris kingi, for instance. I'll show you more information on this right now. The presence of spines or helmets in the Cladocera, especially in rotifers also, but mostly in Cladocera. Their movement, Brachiones versus Hexaptera, for instance, I'll just show you some information. And the ability of some rotifers and some zooplankton taxa to produce chemical substances to avoid predation. So this also is a very important factor that one must take into consideration before beginning or investing in culture. Now let's take a look at those factors related to the predator. For instance, we said about the predator size. So there is a reactive distance. Now when the predator is small, the reactive distance, the distance at which it sees the prey is more. And when the predator is less, and when the predator increases in size, it can recognize its prey at a greater distance. So these factors indicate that you need to provide more prey to the fish larvae when it is young. When it is older, you can provide slightly less prey. It will still see the prey and feed on it. Prey size is also, can you hear me please? Can you hear me?
Yes, ma'am, we can hear you.
Yes, ma'am.
Thank you.
You are quite audible.
Yes, ma'am, we are
Thank you.
hearing and slides are also visible.
Okay, thank you. So now we see the prey size. The prey size also is very important. For instance, if the prey is very small, you need to see it much nearer. If it is large, you can see it at a greater distance. So you need to know that how many rotifers, which are very tiny, that are 250 micrometers, how many rotifers we should provide, and how many cladocera. Cladocera are much bigger, about 3 millimeters, 3000 micrometers. So how many we should provide. The visibility of the prey is also very important. For instance, if the prey have got ephipia or if the prey have got pigments, they are more visible to the fish larvae. Prey movement is important. For instance, that's why copepods, freshwater copepods in special, are not preferred as prey for fish larvae because of two reasons. Number one, copepods in the early stages of growth of the fish larvae can even feed on them. So they are predators, very strong predators. And the second thing is that their movement is very rapid, 80 millimeters per second as compared to 2 millimeters per second in the case of rotifers. So you don't need to give them a prey which is so difficult to capture that they lose more energy capturing the prey. That is why you need to provide them rotifers. If, of course, in certain conditions that you cannot have rotifers, calanoids are provided for marine fish larvae or copepods or herpacticoids are provided. But those also, the younger stages have lower swimming speeds. Now, if you try to culture and you consider Hexarthra versus Brachionos, you should think about the fact that Hexarthra tends to jump in the water and it is difficult for the fish larvae to capture it. Therefore, you must consider what is the correct food. And this can be easily done by you doing some prey preference experiments about which we are just going to speak. Amongst cladocerans, Moina is much faster than Daphnia, but if you provide very high densities of Moina, it will be very useful. And turbidity, sediment or algae reduces prey visibility, so try to keep the species not with so much of algae or sediment that it won't be able to see the prey, but it will be a little sediment is needed to provide contrast in the aquatic medium. Now, this is a very interesting study that was conducted. I think it was by Werner. The fish larvae change their preference depending on their level of hunger. So if the fish is extremely hungry, it will first feed on cladoceran because cladocerans are easy to capture. However, when it is less hungry, it will feed on copepods because copepods have a better nutritional value. So the species, depending upon their hunger level also, they will choose their prey. And then there is the concept of point of no return, which simply indicates that if you keep the fish larvae for too much time without food, even if you give them a lot of food after this said period of time, they will not be able to capture their prey. Therefore, you need to be very careful in choosing the density of prey, in choosing the density of prey and how much time the prey should be given to the larval fish. Now, here, if you take the question of handling time, this is the prey feeding behavioral studies. In this case, we conducted it with Plankton, which is another type of predator. You can also conduct it with fish, like I showed you. And you can see very clearly, you offer the predator two different types of prey of your interest. This was a study conducted by Dr. Sarma by using many rotifers. Not necessary. You just take two species which are growing well in your lab. You offer it to the fish larvae or other predator of your interest, and you see what is the capture success. You see that the capture success, for instance, let's consider Brachyonus caliciflorus, about which we have been speaking, and Hexarthra, which I told you was a species that tends to jump. And you see that the capture success for Brachyonus caliciflorus over here is 0.27 because of the presence of spines or because of other reasons. However, that for Hexarthra is absolutely zero. So there is no point in investing energy and time and effort in culturing Hexarthra if you have the opportunity to culture Brachyonus caliciflorus. So the idea is to conduct this experiment, which will take you no more than 3 days to set up and conduct. And once you have all this data, you know in which species you should put your effort in order to culture it. Now here we see information about the prey density. How much prey should we offer? So you need to offer more prey. I told you about the critical prey density. It decreases with age. So you need at least 100 individuals per milliliter at day 3 for Engraulis mordax anchovies, but only 35 individuals per milliliter at the age of 10 days. So the prey that you offer also should decrease with time. So the importance of zooplankton in fish feeding is in the very early stages. It is really important. And if you invest in zooplankton culture and do these simple experiments, you will get a lot of information which will help you to have a better result from your aquaculture. Also, the light availability, how much light the fish need. For instance, herrings, they change from particulate to filter feeders when the light decreases. So if the light you provide is adequate, they will be feeding on particles individually. Otherwise, they start filtering the water. Functional response experiments are simple experiments that can be conducted. There are 3 types of functional responses that are known in the ecological circles. The functional response type 1, where there is a linear increase in prey consumption in related to the prey density. So what do we study in a functional response? We offer prey at different densities and see how much prey is consumed. Now, this is a type 1 functional response over here. Then we have a type 2 functional response, which increases gently and reaches an asymptote. And then a type 3, which requires a certain period, a lag phase. After that, there is an exponential increase and it reaches the asymptote. Now, different predators have different types of functional responses. Most fish species have a type 2 functional response. Now, what is the use of conducting these experiments? You see over here very simply. You conduct the experiments here. This is another species of godidid. It is a viviparous fish. You see that in the early days, how little prey it is consuming, and prey consumption is increasing with time. The prey consumption also reaches an asymptote at around 4 individuals per milliliter. So if you are going to provide 6 individuals per milliliter, you are only investing in more effort in zooplankton culture. 4 or 5 seems to be adequate for this species. On the other hand, you see this species, which is known as the whitefish or Chirostoma ester in Mexico. It belongs to, I think, Atherinidae. Now, this fish larvae over here, it feeds very little during the early stages, and later on, prey consumption increases. So these are the simple experiments that if you conduct, and that too, this one is with Moina. So you see that this fish larvae definitely will need rotifers during the early days because it practically cannot feed on Moina. And these type of studies are simple experiments that can be conducted, which will show us how or what to offer our species of interest. This is also very useful in this study by Dick et al. Over here. It shows clearly that that function response experiments also are very useful to see the effect of invasive species. So if you have a lot of invasive species in the environment, like we conducted some experiments with tilapia and axolotl, similar experiments you can conduct over here also with invasive species. And this is very, very useful and simple method to find out the impact and compare the impact of invasors on native taxa. Numerical responses are useful, but for invertebrate predators, not for vertebrates that much, because you need to provide the same diet for a long period of time until you can see the investment in its reproduction. With invertebrate predators, it's very clear that you see that when you provide species which are easy to ingest, just 1 minute. Species which are easy to ingest over here, like Brachionus rubens, the predator reaches much higher prey densities than with species such as Hexarthra, which tend to avoid predation due to its ability to escape. So this clearly shows that we should invest more in the production of Brachionus rubens, Brachionus caliciflorus, or Plationus patulus as prey, rather than trying to focus on Hexarthra. Optimal foraging studies began in 1966. In the 1960s, they were very much in vogue in 1960s and 1970s, and many people invested a lot of time and energy also in order to study the role of time and energy in food preference. Now, the predation process, you have to maximize the profit for your effort. As I said, that fish larvae are particulate feeders. So if there is a very low density of preferred prey, they will switch to a non-preferred prey, but because they have to feed and not invest so much energy in looking for the food. Then there are also different aspects which reduce the feeding by fish larvae. For instance, if there is a presence of a predator in the system, they will not feed as much. So what are the conclusions? Simple experiments which you can conduct with feeding behavior of fish larvae is essential to study to decrease the larval mortality in aquaculture. These experiments are simple. They can be done in a very short period of time if they are well designed. If you are skilled in zooplankton culture, it is a great asset indeed. And these studies are very inexpensive. You don't have to invest a whole lot of money to do them. And these studies help a great deal in improving larval survivorship, aquaculture success, and in avoiding waste in resources and effort. Thank you very much. Just a short scene from our campus. Thank you for your attention, and I'm willing to answer any doubts or questions that you may have.
Thanks a lot, ma'am, for such a nice information. Now the session is open for discussion. Participants are requested to unmute themselves.
Yeah, ma'am, it was a nice actually I was listening. And about tilapia, I know that Mexican they are not interested in consuming tilapia, but in India, I have seen that it is a very good preference for the fish eaters. They love eating tilapia here in India.
Yes, but I also heard, I mean, when I was studying fish biology, they told us that in many states in India, tilapia introduction has been banned because it is a very voracious fish and it will displace all the native carps.
Okay.
So that is the problem with tilapia, that it will displace your native carps. But the problem is that native carps reproduce periodically and tilapia reproduces throughout the year. So you have to come to a balance between these two things. Perhaps the taste of the fish is very
Yeah,
good. I'm
good.
not
Yeah.
aware because I'm vegetarian. So
Yeah, I have taken tilapia. It's a really it's a good.
oh,
It tastes
that's
good.
wonderful. Any other question?
I think there is no question. So I invite Dr. Sunita Patra, Assistant Professor, Department of Botany, Government NPG College of Science, Raipur, to give a vote of thanks to Sharma ma'am.
Uh, Thank you, ma'am. I am Sunita Patra. I am from Department of Botany, and it was really interesting because both of the departments they have collaborated together to do this. And of course, this is a collaborative work, because zooplankton and phytoplanktons both are involved in it.
Yes.
And this the topic of this lecture was designing of simple prediction experiments to improve the survival of larval fish. Definitely, if we want to make the endangered species available, we have to look before the survival of larva. Unless until the larva they have taken care of, we cannot go for it. And the experiments were so simple that we can very easily we can do it right from the good feeding behavior, feeding cycle, very interesting. Then prey preferences, prediction processes, and of course, your experiments were based on vision. And I've seen that how minutely we have done. Then olfaction taste, chemosensors. Then of course, zooplanktons they are very good for digestion in this factors. And then what are the different factors which affect food preferences, capture process. Even if the food is available, the distance it matters, the size, the density of the paste also matters. So these are all certain factors which should be taken care of if the larva fish it has to survive. And the most interesting one, the preferences it depends upon the hunger. If it is more hungry, that preferences just like human beings. If we are more hungry, we like different type of fruits. So it is really very interesting. It was a nice lecture, ma'am. Thank you so much.
Thank you very, very much. And I would just like to state that perhaps Dr. Das can share our email with all of you.
Yeah,
And
sure.
if you have any doubts, any questions in the future, please write and we will be happy to respond.
Because it is also available that if the phytoplanktons they are more dense, the larva they are not able to capture their prey. So it is also that in spite of zooplankton, we have also to take care of the phytoplanktons what we are available in the particular environment. So it is very good study.
Thank you.
Thank
Thank you
you
so
so
much.
much.
Thank you.
Thank you. Bye.
Thanks a lot, ma'am.
Thank you.
The next lecture in this session will be delivered by Dr. S.S. Sarma from Mexico. Dr. Sarma will deliver his talk on analysis of water quality using zooplankton indicators and water quality indices. To introduce Dr. Sarma, I invite Dr. P.K. Mishra, Assistant Professor, Department of Zoology, Government NPG College of Science, Raipur. Mishra, ma'am. Mishra, ma'am. Mishra, ma'am, unmute yourself. I think Mishra ma'am is not here due to some. Mishra ma'am.
इससे करी मैम फिर सुनाई आनी चाहिए ना हाँ कविता अनम्यूट नहीं हो रहा है मेरा
ओके मैम हम देख रहे हैं दास मैम
हाँ अनम्यूट है मैम की आवाज आ रही है
ओके मिश्रा मैम यू आर
Hello.
अनम्यूटेड नाउ
यस योर वॉइस इज
Hello.
क्लियर मैम योर वॉइस इज क्लियर स्पीक
हाँ आवाज आ रही है
हाँ बिल्कुल आवाज आ रही है
हाँ ओके हाँ गुड मॉर्निंग एवरीवन इट्स माय ग्रेट प्लेजर टू इंट्रोड्यूस डॉक्टर एस शर्मा
जस्ट अ मिनट मैम आप कैमरे के आगे से अपना हाथ हटा लो ओके स्टार्ट
ओके
हाँ
Is it clear?
now it is clear yeah
It's my great pleasure to introduce Dr. S. Sharma, Professor of the National Autonomous University of Mexico, Mexico since 1995. Dr. Sharma is an aquatic ecologist and known for his research contributions in the field of freshwater zooplankton. He was elected as member of many societies like the Mexican Academy of Sciences, International Society of Limnology, Royal Society of Biology London, and National Researchers of Mexico. He has published more than 300 articles and book chapters, of which 285 scientific works are from JCR indexed journals, including Nature. He has co-edited 14 special volumes for prestigious publishers, including Springer, Elsewhere, Francis, and Taylor. Currently, he is an editor of Rotifer News, a virtual newsletter. He was on the editorial board of various standard journals, including Aquatic Ecology, Frontier in Marine Science, Hydrobiologia, Inland Waters, and PLOS 1. He is reviewer of research projects for national and international funding agencies. He has received about 100 journals belonging different publishers, including Elsewhere, Springer, and Wiley. 75 students have completed their thesis at different levels of university education. Yesterday, he delivered 2 lectures on basic biology of rotifers, cladoceres, and copepods. And the second lecture was ecotoxicology with emphasis on xenobiotics and cyanotoxins. Both the lectures were very interesting and informative. Today, Dr. Sharma is going to analysis of water quality using zooplankton's indicators and water quality indices. I invite Dr. Sharma to deliver his talk. Dr. Sharma.
Thank you very much for your kind words. I share my screen. Can you see the screen?
yes sir
Can you also hear me properly?
yes
Okay, thank you very much. I will put the presentation mode so you can see the you can see the
so you can change it into the slideshow
okay. That's what I'm looking for it. 1 second, please.
okay
Now, can you see it?
yes
Okay. So in this talk, I would like to present something that it can be practiced, it can be done in any laboratory without affecting the teaching schedule that you have. Many institutions, many teaching institutions have very heavy workload. More than 50% of the time is dedicated for teaching, and in different hours of teaching, therefore you have no continuity of carrying out experiments. So this kind of bioindicator importance does not require any culturing nor experiments. So whatever you collect from the field, you fix them fix the zooplankton, and then later on, whenever you have time, and keep on analyzing. So this is helpful to know uh, they classify the water bodies that you have and how they are contaminated or they are not contaminated. So using the standard indices available in the world, we apply for the rotifers. Many of these indices are also applicable for phytoplankton, for other species in the terrestrial ecosystems too. So here I emphasize on rotifers. This can also be useful for Cladocera. Before I start with why rotifers are important as bioindicators, some of these features probably are valid for other groups of zooplankton. First of all, they are widely used as indicators of water quality for over 100 years. And cladocerans a little bit more, nearly last 200 years or so. And the rotifers occur in both planktonic and sessile forms. Most of them are in the planktonic forms. They can be useful as indicators, also sessile forms. Sessile means they are attached with vegetation or stones or any other substratum available in an aquatic ecosystem. They are used there is a difference between bioindicators and bioassay organisms. Bioassay organisms, bioindicators both share only one feature, that is sensitivity to stress. However, bioindicators can be more sensitive than bioassay organisms. If a bioassay organism is very sensitive, but you cannot culture them, such species are not useful for carrying out experiments. So you need to strike a balance if you are using a species for bioassays. On the other hand, bioindicators, you do not have to culture the species, therefore more sensitive, better for the ecosystem, because based on the sensitivity of the species, you can develop water quality criteria, and that will help protect the entire environment. All right. Then the bioindicators, the rotifers alone cannot protect the entire ecosystem. In Europe, for example, you need to study the bioindicator value or bioassay organisms at 3 different trophic levels, at least 3 trophic levels. It can be benthos, it can be planktonic, it can be semi-planktonic or epiphytic. So if you do not have 3 different levels, you are not sure that you can protect the zooplankton. This is one of the reasons. However, this topic is sufficient to give an indication the water quality. The samples are collected from the field, and normally no live sample is necessary except for taxonomic resolution, especially the planktonic species, the sessile species that you need study the live forms to see the coronal structure and body structures. But otherwise, field samples fixed samples are sufficient for study for a long time. It has one of the greatest advantages is that you Professor Kanungo mentioned, that the species collected now can be used after 25 years too, to see what kind of changes have taken place in the given water body due to human activity or global warming or any other factor. So the samples can be used. Okay. In bioindicator studies, you will find 3 terms possibly with the overlapping meaning: environmental indicators, ecological indicators, and biodiversity indicators. Environmental indicators do not necessarily mean only organisms. For example, the concentration of the carbon dioxide in the atmosphere from time to time, it also indicates an environmental variable. The ecological information usually related to the prey-predator interactions, and they do not consider the taxonomic importance. Therefore, it is a functional based study. Biodiversity indicators usually care for the species diversity, but do not consider the morphological changes that you encounter in a given group of organisms. However, there are other terms too. Compliance indicators, for example, what is the minimum level of performance of a given species in a given ecosystem and is subjected to stress, or diagnostic indicators of what are the factors that determine the impairment. It could be swimming speed, it can be the velocity of capturing the prey, any such thing. The third one is the early warning systems. They give indication. Normally, the ecosystems or they show resilience. In other words, the same species composition remains year by year. The flux densities vary according to the month of the year, the season, the temperature, pH, salinity, and so on. However, the same species will occur time to time. If you make for about 20, 30 years of data, every year the same species more or less occurs. But what differs is the density. However, as toxicants enter, they disrupt this composition of the zooplankton, and or even within the rotifer community, the composition changes, and this can be studied based on 2-3 years of data. We can consider that there is some problem going on in this affecting the composition of the rotifer community, and therefore we need to take appropriate steps. Then next is bioconcentration, bioaccumulation, biomagnification. There are 3 terms. Sometimes they are synonymously used, but there is a specific meaning. Bioconcentration means normally when an organism is exposed to a toxicant without food, from the medium, directly the organism picks up some concentration. For example, take the rotifer Brachyphanes calciflorus. We keep them in a container containing calcium compound or magnesium or heavy metals like mercury. Then a certain portion of this concentrated metal enters directly the body of rotifers without any filtration, without any food. But if it accumulates through food, that is called bioaccumulation. Biomagnification usually at a higher level, where the dietary intake, if one rotifer has consumed 10 algal cells, and each algal cells contain 1 microgram of a substance, and if these microalga, these algal cells accumulated in the body of a rotifer, and if 10 such rotifers are eaten by 1 fish larva, you will see each time it is multiplied by 10. So that is what is called biomagnification. It is not directly through food alone, but it also affects the next level. Then another term which is commonly found in literature is the bioindication. It has got 2 parts. Part 1 is bioindicator, and part 2 is biomarker. Biomarkers are usually experiment-based one, molecular-based one, and for that you need the live sample. So I will restrict my talk only to the bioindicators. And I do not also venture to define, redefine, or to raise various concepts that are already available, or to give a reinterpretation. But this is mostly to deal with what we can do here. There are 2,000 species approximately of rotifers. Unfortunately, only a fraction of them are used for ecotoxicology. Although bioindicator study is inexpensive and does not involve full-time labor, yet published literature shows only 5%, less than 5% of the works deal with the ecotoxicology, and 95% of the works deal with the experimental ecology. So what are the advantages of using rotifers? These advantages are similar to many other groups, including the Cladocera. However, there is some variation with reference to the specific properties, characteristics of rotifers. First of all, they are ecologically relevant. You are not bringing a sample from outside your country. There is no point of bringing a sample from Scandinavia and study here, because the conditions are different. So what they indicate in Scandinavia may not be the same here, what you find in your local samples, therefore ecologically relevant. One of the problems of ecological relevance is using the Daphnia magna. Daphnia magna is a cladoceran which is not found in tropical countries. And any ecological data that any ecotoxicological data that you collect on the Daphnia magna is not applicable to your fauna, because it is not found locally. So ecological relevance means you study those species that you see them daily, or at least monthly. Okay. Then they are also sensitive indicators of quality. For small changes in pH, temperature, salinity, and any other variable, they also respond. They respond differentially. Sometimes presence and absence of the species, sometimes changes in the abundance of relative abundances of the species composition, and so on. They also respond quickly. You do not have to wait for 5 years to see if there is any change. No, you within a month, sometimes within a week, you'll find in a acute toxicity test, you know that they will change rapidly, sometimes within 24 hours. Also, it happens in nature. When industry suddenly pumps out uh, toxic substances in the medium, next response is many species of zooplankton, including rotifers, disappear, or at least their density falls down. They also indicate the cumulative changes in the functional, demographic, population, community level responses of organisms. What you see right now, the composition of the zooplankton, composition of rotifers, is a cumulative effect of many of these functions. And the methods are non-destructive. You do not have to sacrifice an animal. If you have zooplankton collections, very few individuals you have, you do not have to sacrifice them for anything. You simply use them morphologically, counting and what species are there, how many individuals of each species. That is sufficient to give us information about the water quality, about the quality of the water in a given ecosystem. Fortunately, we have about 2,000 rotifer species. If you have only 10 species of a group, then one species disappearing, it gets 90%, already 10% error in your calculation. If you cannot identify to 10 species, one species, it means 10% deficiency in your estimation. If you have 2,000 species, not all the 2,000 are present in a given water body, but normally, as I mentioned, at least 50 to 60 species are common in a given water body. So one or two species, if you do not identify, it will have less than 2% to 3% error in our conclusions. So it doesn't make much statistically much problematic. And many groups, many genera of rotifers, many species are taxonomically well defined. There are guides available, identification tools are available, identification literature information is available to arrive at species level identification. They also have wide distribution. You find them in almost any given water body. Freshwater or marine, there are about 250 or 200 species of marine rotifers, but this talk is mostly related to the freshwater. And collection methods are, as I mentioned yesterday, they are very easy. What you need is only a plankton net and formalin. That with that you can preserve the sample for a very long time. And we have seen the samples preserved in the British Museum, and more than 300 years. The samples are still there. So they can be analyzed to see historical changes in the aquatic ecosystem. Sometimes the resting eggs also will be helpful to identify what species existed in a given water body before it dried. There is also high correlation with the food availability and rotifer density. So very high densities generally indicate that there is a high food availability. It could also be a eutrophic condition. I will consider this in the next slide. And there are smaller body size. And therefore, when you collect the samples, you do not need a very big jar to preserve them in 100 ml, 50 ml containers are sufficient to store them. And they have, because of the high abundances, the high taxonomic resolution is possible. But it's not that rosy using rotifers as a bioindicators. There are some problems. First of all, Delide group, as I mentioned yesterday, that they are about 500 species, or 25% of the all rotifer fauna known in the world, and they are very resistant. Because of the anhydrobiosis, they can resist any hard conditions, and they are not useful really as indicators of water quality. Experiments can be done with them, of course, but they are not really they are not really sensitive to changes. And second, their morphology is more complicated to identify them because all delites can be only identified when they are living. When you fix them in any form, the corona loses its contracts, and therefore they are difficult to identify. You need foot opening, foot and corona are important characteristic features. Tropha is not really useful in this case. Okay. Then on the other hand, we have monoclonal rotifers. They are about 1,500 species, and so much work is done only on this group and less is done on the Deloittes because of the problematic situation. Taxonomic problems still exist in the many groups, species complexes of rotifers today, because molecular tools are not sufficiently employed because of the difficulty. The taxonomists, more conventional taxonomists, to consider only morphological taxonomy as the basis, normally do not have the skill to culture. And those who culture do not have the skill to identify morphologically. And these two groups cannot interact very well with the molecular biologists. That requires a special kind of equipment and special knowledge to interpret the data. In certain cases, like some of the sessile rotifers, you need live samples. This cannot be denied. However, the most planktonic species, you do not need this live sample identification. Then you also have, there is like any other study, there is no hierarchy or scaling in the using rotifer indicator. Which indicator has the highest value, which indicator has the lowest value, and what is the scaling? That doesn't exist in the case of indicator biology of rotifers, possibly other groups too. And one-time sample collections sometimes can be misleading. If you collect samples in the winter where much of it is frozen, for example, in the high altitude water bodies, then you have low diversity, but it doesn't mean that the diversity is low. In summer months, it is possible that you have very high diversity. So density, not only diversity, but also density. So the density, once you use density-based indicators, which I will show you now, then it can be misleading. Therefore, you need to collect the samples through seasons, at least for certain water bodies. In spite of the fact the water quality criteria is largely based on bioindicators. They indicate something which instruments cannot indicate. For example, if the extremely low concentration of mercury, cadmium in a given water body, the chemical analysis does not give anything. Sometimes this is a sensitivity of the equipment, the precision, what you call a precision of the equipment, fails to detect the concentration of these of such metals, whereas rotifers show extremely, because they are very sensitive, so they show changes in their abundances or a complete absence of the of certain species. So this aspect, that one I would like to. In addition to the presence and absence of the species due to stress, they also indicate habitat type. They also indicate geographical distribution. Some of the species are restricted to certain continent. So based on that, if a given sample is observed by a typical taxonomist, he could tell you that from which part of the world a species is taken. Notalka, for example, is obtained definitely from the cold waters. It's not definitely from the tropical waters, except a marine sample. So, like that, there are also indications that whether which geographical part of the world the sample has been taken. Now, there are different types of bioindicators. So, in this case, as rotifer, here I give you a panoramic view of what I would like to talk. Bioindicators are based on the presence, absence, or species richness and density, or changes in the morphology, or the accumulation of substances. All these are the central core for using bioindicators. Value of, you also find, if you are good in taxonomy, you will find which species alien, which species not alien. Alien species, here I would like to say, rarely you see them. Exotic species, you see them commonly, but they don't do any harm. On the other hand, you have what is called invasive species that interferes, the density of such species interferes with the local ecosystem, causes changes in the species composition of the taxa. An invasive species, for example, Brachyonus hawaiiensis, which is not found in Europe for many years, and now it is found in Spain and a few other countries. So what it does, it dislodges local species, for example, Brachyonus angularis, Brachyonus calciflorus, and other species. So this is called, this is what we call invasive. Invasive means the exotic species, it becomes it interferes with the local structure, composition, and function of the local ecosystem. So these are the three groups. Brachyurus josephinii is a species typically found only in Mexico. Now it has been reported by Shield in Australia, but only once. He has not reported it anymore, and no other part of the world it has been reported. So it is alien. Okay, exotic species Calicotia expanding, it is from the Brazil and then expanding to the Europe and other parts of the world. They also indicate habitat type. The given species, the benthic, pelagic, or epiphytic, you can easily know based on that, and geographical location, and the ratio of different types of morphotypes. They also have different types of morphology, and this morphology can also change in relation to the toxic and stress, sometimes malformation, but still live, still active, still reproducing. Yet the morphology is different from typical morphology that you find in the uncontaminated water bodies. Then conflictive interests are there in aquaculture and biodiversity, a bioindicator of pollution. For example, rotifers indicate indicators of pollution, presence and absence, their densities, and extremely high densities indicate productivity, because this is what is required for a fish farmer. So when a water body has got abundant densities of zooplankton, then he will introduce fish larvae to feed on them. So there are also indexes based on abundances alone without identification of the species. Then of course the trophic state index, the saprobic index are all available. Then you also have the Simpson, Shannon, Wiener. These are diversity indices. They are independent of the taxonomy groups. So you need to know the different species or different genera that is sufficient to derive these indices. They don't depend on the species identification. You also have multivariate analysis that you have listened a presentation by Professor Kanungo. The densities composition changes do not depend on a particular variable. It can be calcium, it can be pH, salinity, temperature, many other variables interact. So you need a multivariate analysis to see which species responds to the combination of these factors. Then sensitivity is a very important factor. The species very sensitive simply disappears from the ecosystem. So resistant species only are present in contaminated water bodies. Usually you find deloids. Monogram rotifers, majority of them disappear. So you also have got what you call a sentinel species, or these species we call the police species. They indicate directly what is going to happen in a given water body. Then you have biosensors, you detect the pathogens in the prey. This also has been found. Then bioaccumulation, biomagnification, bioconservation, then the densities of two species can be used as indicators. As indicators, usually two species. And then you also have other indices specific for the rotifers, depending on where they are found. For example, shallow lake water body, shallow lakes, you have different types of composition. Most of them are benthic or epiphytic, and then they have different types of indices that can be derived. And I did some of the examples of each of them. You will find that Adenata vaga, for example, is African and Palearctic region. You don't find in other regions. Then Horella thomsoni, for example, is near tropical region, and you don't find in other countries. Keratella procorva robusta is a typical Australian species, and you don't find other. Lecane yeseni, you will find it in China. You will also find in recently we also found in Mexico. I don't know how, but some of these species that possible because of the Chinese Mexican government and Chinese government, they receive a lot of products through ship, and then they carry what you call it, the ballast water, and it is possible that there's this kind of anthropogenic distribution of the species. And like this, based on the species that you find, we will come to know from where they are originally from. All right, some of them are still, some of the species still have restricted distribution. Now, they also indicate habitat type. For example, many species are typically planktonic, as Brachyurus, Neurops, Keratella, Naphalka, and so on. There are also semi-planktonic species. There are also type of planktonic. There is a pseudoplankton, that is sometimes they are found in the pelagic system, but they are not, their habitat is not pelagic. But when the abundance is very high in the periphetic zone, they compete with each other, and then the best method to escape the competition is to come to the pelagic water bodies, pelagic part of the water body. Then you also have typical benthic species, Chlorella, Aspelta, and so on. Episodic species like Brachyurus urubens, it attaches to the carapace of Cladocera or any other substrate. Then there are also few parasitic species, and they are parasitic on animals or parasitic on uh, plants too, and phytoplankton, but Gascomorpha volvosicola, for example, when the volva colony it enters and then gradually eats away all the small future colonies that are being formed, and is a parasitic one, and it cannot live without this host. Then, based on the where they are found, some ratios. Professor B.K. Sharma of Shillong developed a ratio of Brachyurus to Lecane. Lecane is a genus that you find always as um, literal periphetic species. Very few species are found in the planktonic condition, whereas Brachyurus, all the species of Brachyurus are planktonic. So the relation between these two indicates whether the sampling is done in the limnetic habitat or semi-limnetic or lateral periphetic habitat, depending on the ratios. This is also used in some cases. Then the next part is correlations. There are certain species that typically acidic water, Spelta, for example, they can tolerate up to pH 3, very close to that. And Polyarthra erectora, the same thing. And there are certain species that tolerate high alkaline conditions. For example, most species of Brachyurus, and when the acidification takes place, these species disappear immediately, almost in less than a week. And although vast majority of them ionic, in the sense that they can tolerate from all the way 6.5 pH to 8.5. And certain species tolerate low dissolved oxygen, for example, Carotella tisniensis, and some species require high oxygen concentration, mostly species of Nothalca because they are riverine species. Now, the bioindicators are also in relation to temperature. Some species prefer low temperature, some species prefer high temperature. Most tropical species, Brachyurus, Trichocerca, and so on, they need a temperature above 15 degrees centigrade. And there are also a group of species, Nothalca, Splankna periodonta, Philinia, Hoffmanni, some species of Cinchata, they need low temperature. If the temperature of the water body is higher than 15, say 20 degrees centigrade, these species do not survive. Therefore, you cannot culture them. If you want to culture them at this temperature, you need a lower temperature. And salinity, of course, most rotiferous are freshwater. More than 90% of the species, they cannot tolerate salinity. 2 grams per liter of salinity, most of the species simply do not survive. They all of them fall dead in the container. However, there are some species which are euryhaline, or some species which are typically found only inland saline waters. Saline waters, we define that salinity can be comparable to that of brackish water. However, this water body has no relation, has no connection with the sea. That is why it is called saline water. Some of them, Hexatra jenkini, Lecane lamellata, you find them in inland saline water bodies. And the low salinity, most species cannot tolerate salinity. As I mentioned, they cannot swim also, they cannot reproduce. Their survival is threatened in that case. And high salinity species of Brachyurus plicatus, it can tolerate up to 45 to 50 grams per liter of salinity, is higher than the saline, higher than the marine water, so they can tolerate. Okay. Now, low salinity, this is an example taken from literature that when the salinity increases, only 2 species can survive, Hexatra jenkini and Brachyurus dimidiatus. Plicatus is euryhaline, it can also survive, but as the salinity is low, then there is a change in their composition and abundances. You will see that one. Then they also have some good correlations with the nutrients and the rotiferous species density and diversity. High nutrient levels generally are required for Carotella. Whenever Carotella quadrata, Lecane, Stichia are present, it means the high nitrate levels are present. when the nitrate levels are low, then another group of rotifers appear. This, for example, Brachiosaurus. Then the same thing also for phosphate. The same thing also for other elements in the aquatic ecosystems. Then what about the trophic condition? Conventionally, you can have three basic water quality: oligotrophic, mesotrophic, and eutrophic. And based on the direct observations from where these species are collected, whenever you see Synchyta stylata, the water body is oligotrophic. It means a transparency of Secchi about a meter or even more. Eutrophic is Brachionus. Species of Brachionus, you don't find them in the oligotrophic water bodies. They require a high content of organic matter, especially the phytoplankton concentration, so they can survive. Some of them are transient. They can be found in oligotrophic to mesotrophic, sometimes to eutrophic too. Then what about the response? How they respond? The response of rotifers to stress can be variable. First, most common is the presence and absence. If it is present, that means that if they are absent, it means they cannot resist the stress. They are sensitive. This is the general philosophy of this indicator. Brachionus, for example, is typical in eutrophic waters, and Trichocerca is common in oligotrophic. And Brachionus species of Brachionus do not live in oligotrophic waters, and Trichocerca does not live in eutrophic waters because it requires low phytoplankton density. In high phytoplankton density, it cannot survive. It is also associated with the phosphorus nitrogen relation. So the ratio between these two can indicate whether the given water body is oligotrophic or mesotrophic. For that SLAD check, a Czech researcher developed many decades ago. If more species of Brachionus, is not the density of the Brachionus I'm talking about, is not the density of the species of Trichocerca is independent of the density. Here you need to have taxonomic skills to identify different species of Brachionus, different species of Trichocerca. Both have approximately 70 species in the world. So if you have the taxonomic skill, then you can see how many species of Brachionus are present in a given water body and how many species of Trichocerca are present. And if there are more species of Brachionus and less species of Trichocerca, the ratio is more than 2, then it is called eutrophic. But there are more species of Trichocerca, few species of Brachionus, it can be oligotrophic. High altitude water bodies pose a great threat to this formula. We did not find this acceptable in Mexico in certain high altitude water bodies because the water temperature is very low and eutrophic, but Trichocerca is abundant, or oligotrophic Brachionus is present. So these kind of complications are present. Therefore, more research is needed, especially high altitude tropical water bodies, how this relation changes. Now, a relation in correlations with reference to cyanobacteria. Yes, most species of Brachionus, for example, they are capable of feeding on only individual cells of cyanobacteria, not a colonies. The moment colonies appear, Brachionus species disappear. There are some exceptions to this in automata. For example, Itura, they feed on cyanobacteria. Somehow they resist the cyanotoxins and then they keep growing. And one of the famous examples is the Brachionus dimidiatus, which feeds on spirulina, is also cyanobacterium. However, it's an edible cyanobacterium. It's one of the few species of cyanobacterium that are cyanobacteria that are useful for consumption, including human consumption. And Brachionus dimidiatus feeds on, though this spirulina is in the form of filament, is a filamentous form, they still feed on such filaments, regardless of their length. And some species of sessile rotifers, which are normally associated with the macrophytes, they indicate the changes in the level of contamination because they remain there from birth to death. So there's no change in their movement. They remain there because they are attached. And there are also sentinel species, the early warning species, as I mean, they become more and more This is a good definition that you find. Sometimes it is for birds. It is especially true for birds that common species are becoming rare and sometimes rarest. So this, if you do not notice that, considering that a common, for example, a house sparrow in Europe is gradually disappearing. It was there because food is not anymore thrown outside, and the forest is depleted, and they have no insects eating because most of the people apply various kinds of pesticides to their garden for the plants, and then no more insects. So the number is gradually decreasing. So they have been encouraged, the locals have been encouraged by the government to put some nest for them and so on. So this is another problem, that if you do not notice, some of the most common species disappear. One example we have in Mexico, the Brachynes rubens, which was abundant 30 years ago when we started collecting every water body almost we find it, but now it's not there anymore. We don't know why. It could also be the environmental factors. Then if you do not have the capacity, or if you are not interested to identify the species level, excellent. Whatever you can say that it is a rotifer, it's a non-rotifer, that is sufficient. So the densities of all individuals of all rotifer species together, if the number is per liter is less than 500, oligotrophic is between 500 to 1000 is mesotrophic. It is valid for most water bodies. Also, hypertrophic water bodies, we have sometimes 5,000 rotifers per milliliter per liter, or 5 rotifers per milliliter you find, and that is hypertrophic water bodies. This ratio, this densities, direct indication of the trophic level. This is an interesting one you can find. We applied this one to various water bodies in Mexico, and some of the drinking water reservoirs, we have very low density of rotifers. They are indeed oligotrophic by any other method, including the nutrient estimations and absence of cyanobacteria and so on. You will find that they are oligotrophic. This also indicates that the 500 individuals per liter, this density of total rotifers is also valid for under such conditions. And now there are also species diversity measures. You already know alpha, beta, gamma diversity. Then you also have momentary diversity. This is interesting to know. And then very low diversity in the saline water. This take up rapidly. That alpha diversity, generally it means that the presence of the species in a given water body. And beta diversity is 2 or 3 locations. How many of them are common? Here, example, you have 2 lakes, Lake Xochimilco and the reservoir Y de Bravo, and one water body has 56 species, another has 36, and the difference is what we call beta diversity. And gamma diversity for a large landscape, for example, of a country. I give an example here. Okay, the momentary diversity is the one that you normally detect. So you don't collect samples periodically, you just collect one-time collection, point collection in 1 month when the conditions are favorable, or whenever you travel to some place and then you find a water body, and then if you are a typical zooplanktonologist, you always travel with a mesh. So you just go and then collect a sample in a given water body, and then this is a momentary water body. However, it differs when you make sampling periodically or monthly over a period of time. Here is an example: momentary diversity of rotifers in Y de Bravo is a reservoir in the state of Mexico is only 28. However, long-term studies indicate 50. And in some cases, rivers, especially extreme numbers, can be there, almost double the density. For example, in the river Antigua, in Veracruz state, that we have 61 momentary. At any time, you find about 60 species. However, you keep on collecting in different seasons, you find the number is more than 120. This is long-term diversity. Then diversity indices, you already know the Margolef, which is very commonly used, and the ranges from 0 to 8. That is the range given by Margolef, and then if the value is 0, it means a very low diversity of the species. Then the Shannon diversity indices, many young researchers consider Shannon Weaver, but actually Shannon Wiener is correct. According to that, is the same person that worked in the Bell company. Now AT&T company is the same, transformed from the Bell, and he was working as he's a mathematician. And in those days, a telegram is cancelled, I think, in India. In many countries, it doesn't exist anymore. So when you want to send telegram from one place to another place, they charge you by word. So if you can remove certain words without affecting the meaning, that will be better for the user, and people go to such companies. So he was doing that job mathematically, deleting certain words, but without affecting the meaning, so that the user will have to pay less amount of money. And in the same way, his formula is very useful for us. If you cannot identify one or two species in a given water body, it does not affect the diversity. Diversity index, that is what he developed, and later on it has undergone some modifications. So there are a dozen of them commonly used for rotifers. The Berger, for example, or Fisher's alpha, Diver, Margolef, I mentioned Simpson, for example, is the beginning of that, and the modification of that is Shannon Wiener, and the similarity of the Sorensen already. Professor Kanungo mentioned the same thing for comparison of two the water bodies. Then we have here some quantitative data from a given water body in Mexico, that similarity, evenness is similar, very close, that high distribution and pattern of distribution, abundance of the species, but the species are different. But the Shannon index can range from less than 2 to 4, and we never get 10. In order to get Shannon index of 10, you need about 100,000 species. That is just not possible in case of the rotifers. The maximum number, we have only 2,000 species. And we also applied the Shannon index to various water bodies in Mexico, and these are usually the drinking water reservoirs, the value that we find is maximum 2. Still, this is interesting for us. And saprobic index, there are 3 basic types. 2 of them are not really useful. That cathodic in the saprobic image, it has no organic material. No rotifer can ever survive. If you find in the drinking water reservoir, in the tap water, if you find some rotifers, it means that there is some problem, supposed to be without any organic matter, and it means that the pipeline has some organic matter accumulated over a period of time that requires cleaning. And transaprobic is extremely toxic. Usually the plastic, microplastics, so you cannot clean that with any. No rotifer can ever survive there. So only rotifers can be used as indicator of saprobic for value, limnosaprobic and eusaprobic. Limnosaprobic generally is organic matter in the fresh water, and eutrophic, eusaprobic, of course, for the seawater, sewage water. So there are also indications. You need only 3 variables: species richness, it means you need to have the capacity to identify the species level and the relative frequency of them, and the species specific saprobic index already developed by Sladchek. You simply have to apply them. And we use this one. Most water bodies, not only in Mexico, but most tropical water bodies usually have beta mesosaprobic value. This is normal observation based on many. Then we also applied this one to 3 drinking water reservoirs in Mexico. They also indicate that most of them, their beta mesosaprobic index. Then what about morphological? The density is the same, diversity is the same, yet the morphological aberrations are possible. You see on the right side of this figure, Caratella americana, it has a tendency, most species of Caratella have a tendency of malformation of the lorica when exposed to heavy metals like copper. In copper contaminated water bodies, you find the left side one is original. I mean, it's normal. Under normal conditions, this is how it looks without contamination. But the moment the animal is exposed to heavy metals, usually the copper, then this is a malformation of the spine. It is not bent by us. It's naturally, it develops this malformation. It means something wrong with the water that you need to check. It is a kind of warning for you. The density can be the same. The morphological features are the same, except then you also have the Caratella taurocephala usually in Canada, this you find. And in metal contaminated or esterified lakes, it is abundant. When it is non-esterified, then the density is very low. This is also direct indication. Then Edmondson's egg ratio can also be used. The number of eggs that a rotifer can carry is an indication of the food availability in the environment. Then you also have alien species. They cause some kind of distribution, they got disturbance in the given water body, then they become First, it becomes exotic, then it becomes invasive. We found this Brachynes havanensis in Spain. It was not there before, and then we have been working in a given water body for 5 years, and suddenly in the last year of our study, we found abundant densities, abundant individuals of the Brachynes havanensis. Later, we came to know that this is invasive. In the beginning, the distribution of rotifers, Brachyne rotifers in this water body is more or less balanced. Then the moment Brachynes havanensis appeared there, then some species of Brachynes, especially Brachynes angularis, began to disappear or at least reduced abundance. So, in order to know if alien species become exotic or not, what we need to do is to collect from the same site monthly for some years. And if the abundances increase, it means there is a tendency of alien species becoming exotic. Now, if exotic species become really invasive or not, you need to study much more than other species too, and how their densities vary in presence of the exotic species. Then if the Keratella and Polyarthra, these two species share much of the burden space in a given water body. So the ratios can also be a good indicator of the status of the water body. Then there are specific rotifer trophic state index. In this case, you do not have to again identify the rotifers to the species level. If you know the total density of all the individuals of all the species of rotifers together, then you apply this formula. It gives you mesotrophic, mesoeutrophic, eutrophic, and hypertrophic. But this formula fails with oligotrophic because there is no reliable formula for that. We also applied the TSI rotifer index for many water bodies, and in Mexico it applies very well. And by this method, what I would like to conclude, first of all, the use of rotifers as indicators of water quality with reference to Mexico has been presented here. I have also examples from other countries, and due to their ecological relevance, sensitivity, high species diversity and density, you can still use rotifers as good indicators of water quality, as has been done in many other countries. Then the selective physicochemical variables, they only by correlation method. There is no direct relation. In most cases, multivariate analysis needed to decipher the relation between the species abundance density and with physicochemical variables. Different indices like Shannon, saprobic, they are all TSI, they are all specific. Only TSI specific for the rotifers. They can also be useful for other water bodies, as we have been applying for certain water bodies in Mexico. Then the Sladacek ratio of Brachynes to Trichocercas, unfortunately, it is not fully applicable for certain water bodies, and it requires further study. Also, which species of rotifers that you have, the species diversity in India is different from that of Mexico. Certain species are not found at all in Mexico. Many Mexican species, some of them are not found here either. So, because certain species are different, you need to develop your own indices and how that can function to enhance the value of indicators, and that way you can classify your water bodies. I thank you very much, and I will be happy to answer your questions.
Thanks a lot, sir. Now the session is open for discussion. Participant can unmute themselves to question.
So I am asking a question. We can use these planktons as a pollution indicators.
Yes, but they are not specific. Pollution due to what? Heavy metals, pesticides, or both? So
Both,
this
sir.
is why
General pollution, sir.
Yeah, it can be useful. That's why I told you there is no hierarchy. They cannot specifically indicate due to what, except possibly Keratella, the species of Keratella. If there is a metal contamination, they show some morphological aberrations. But all others show their changes in the density or abundances or species richness.
Okay. Sir, according to richness, species richness, we can classify ponds as a polluted plant or non-polluted plant.
Yeah, you do. Yes, you can. But you need a reference. Which water body in Mexico, by the way, which water body in India, by the way, is not contaminated?
No, sir. We in Chhattisgarh we have maximum ponds. So if we study the different ponds, so we can classify their in
Exactly. That is a very good idea. If you have 50 ponds and then if you study monthly for 50 ponds, enormous data you generate, and the indexes that you develop, they can be really a great contribution to science.
Okay, thank you, sir.
Any other question? Okay, I think there is no more question. So I am thankful to Dr. Sharma for such an informative lecture. Dr. Sharma told about application of rotifers as bioindicators to analyze the water quality. He also emphasized the role of rotifers as indicators of habitats as well as geographical distribution. He elaborated how the distribution of rotifers vary with the different physico-chemical characteristics of water body, example, salinity, pH, temperature, depth, etc. He also elaborated their role as an indicator for different trophic level and species diversity indices. The lecture was very relevant in present day scenario, as we all know that the water is utmost necessities for all the living beings. And due to the increasing pollution, water quality is decreasing day by day. Thus, to analyze the water quality, one can exploit the rotifers as bioindicators. As the method is inexpensive and does not require any destructive techniques such as killing of any animal, it can be used anywhere. With these words, I again extend my thanks to Dr. Sarma for his very informative talk. Thank you, sir.
Thank you very much.
थोड़ा आप सीधे हो जाइए, एकदम साइड में आ रहे हैं लाइट सर, थोड़ा सा सीधे होंगे तब फिर
लैपटॉप बीच में ले जाओ, लैपटॉप ठीक कर दो। हाँ, आप ठीक है, अब ठीक
है।
मैं और पास आ गया। लैपटॉप की पोजीशन ठीक कर दो।
सबसे बाएं हाथ वाला है ना? हाँ, सबसे इधर वाला।
Now, the next lecture in this session will be delivered by Dr. M.L. Nayak on water quality and planktons in Chhattisgarh. To introduce Dr. Nayak, I invite Dr. Shashi Gupta, Assistant Professor, Government NPG College of Science, Raipur. Gupta ma'am.
Yes, thank you, Sinha ma'am. A very good afternoon to everyone. It's my pleasure and honor to introduce our guest speaker, Dr. M.L. Nayak, sir. As such, he doesn't need any introduction, but since I am asked to do so, I'm doing it. He's my teacher and is a gracious and who has graciously accepted our invitation to join us today. Dr. M.L. Nayak, sir.
शशि, अब बस हो गया, बहुत ज्यादा मत बोलो।
थोड़ा सा तो बोलने दीजिए सर, थोड़ा सा, बहुत शॉर्ट।
अरे अच्छा, अपने फेस पर लाइट करो, पीछे से लाइट है तुम्हारे।
अच्छा जी 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 जी।
अभी स्क्रीन शेयर करेंगे,
अब ठीक है, क्लियर है?
नहीं, बहुत क्लियर। पीछे बैक साइड का लाइट तुम्हारा ज्यादा हो गया।
जी करती सर जी। महेश,
हाँ ठीक है, बोलो चल।
ठीक है सर जी। Dr. M.L. Nayak, sir, is highly accomplished individual in the field of environmental biology, pollution biology, industrial microbiology, plant tissue culture, biodiversity, and forestry. And he is Head and Professor, Institute of Life Sciences, PTRSU, and he's having teaching experience of more than 41 years, got more than 70 papers of research papers published. Number of students who has been awarded PhD under his guidance are 40, and presently he's just a minute, please. Member of
ठीक है
Biodiversity Board.
Biodiversity Board, and now I invite sir for his lecture.
सर आप कहते हैं वो आपको इंट्रोड्यूस नहीं कराइए, देखिए आपके पुराने स्टूडेंट सुमना जुड़ी है आपका लेक्चर सुनने के लिए फ्रॉम कनाडा। कनाडा
नहीं वो सबसे पहले मैं उसी को थैंक्स दूंगा कि इतने रात को भी वो लड़की अभी 2:30 बज गए रात के।
प्रणाम सर।
आपके लेक्चर के लिए जुड़ी है सर।
कुछ रहो वही मैं देख रहा था सुमना जाग रही है कि नहीं, तो अभी जाग ही रही है।
आपको सुनना ही है।
अरे नहीं, अब मैं कहाँ, बहुत ओल्ड हो गया, अब कहाँ ये सब जो है ना।
2 बज रहे हैं इधर, 2 बज रहे हैं।
हाँ वही ना, 2-2:30 बज गए अब रात के।
कोई बात नहीं, आप सुनाएं आपका। हाँ, वी आर वेटिंग फॉर योर लेक्चर।
वेलकम सर।
जी हाँ हाँ भेजे हैं। एक लेक्चर में हूँ, मैं लेक्चर दे रहा हूँ, तो मैं आपसे बात करता हूँ।
ओके कर दीजिए सर उसको। या अब दिख रहा है सर। अनम्यूट कर दो गुंजन सर को।
सर को अनम्यूट करो आकाश। हाँ
आया।
हाँ
यस सर।
So first of all, thank you, Sumna, that still you are awakening even at 2 in the night. So, dear parents, actually, I'd like to accept outset at this point that I am an old man and I have not much work on these planktons. Whatsoever today I was listening some of the talks, very interesting they were, particularly on the rotifers as bioindicators and other lectures. So my lecture will be rather not so specific. It will be more generalized on the water bodies of Chhattisgarh. Chhattisgarh state is actually known as the ये किधर से आगे किधर से बढ़ेगा? नहीं उसे नहीं जा रहा। So Chhattisgarh state is known as the state of ponds, where particularly in the central part of Chhattisgarh, every village has at least 1 or 2 ponds, and there are reports that some of the villages still have more than 100 ponds, and in one village, that is Chote Dongar village in remote Bastard area, The village has got as many as 150 ponds. This Ratanpur village, the earlier headquarters of Chhattisgarh, has still more than 120 ponds. So planktons are very important for Chhattisgarh due to the abundance of ponds. Now, before going in about the ponds of Chhattisgarh, I would like to give some idea about the water. Water has some very peculiar properties. H2O, it is we know, but very interesting is that at very low price or low temperature, when it becomes solid, it becomes lighter. As well as when it becomes warmer, even then again, it becomes lighter. So its maximum density is at about 3.94, or what generally we take it as 4 degrees Celsius, where its density is maximum. Now, what is the advantage of it becoming lesser denser when it is solid? That when it forms ice or solid, it floats on the surface of water. That helps whenever the weather becomes warmer, the floating ice is there, it then gets dissolved into water. So that is the advantage. Had it been that if the ice would have settled to the bottom of water bodies, then probably the most of our water bodies presently would have found to be frozen. Now, water, it is taken way. 1 liter of water at 1 atmospheric pressure is almost taken to be
Hello?
1 gram. That is the unit of weight, although a little, very fractionally little than 1 gram. But in the general way, we take it to be 1 gram. Now, what is interesting is that the plankton, they have got density always more than 1. So generally 1.03 to 1.1 gram per cubic centimeter or 1 per cc, the planktons have their density. Now, it is interesting that many of the planktons, they don't have any swimming ability or moving ability. So how these planktons, they keep on afloat, how they keep on themselves on the surface of water bodies. That is very interesting. If the water, it becomes totally calm, then these planktons, they are doomed to go down to the base of the water bodies. They simply sink down. So it is important for the planktons that the water, it has got turbulence, it is in moving condition. With this, there are several physicochemical properties which affect the plankton, particularly when we go to oxygen. Oxygen, as far as its solubility is concerned, it is supposed to be sparingly soluble. Oxygen will require to become saturated up to 1 centimeter depth. If the water, it is still, it may take almost 4 to 6 months. That 1 centimeter water depth, it gets saturated with atmospheric water. So much sparingly soluble the oxygen is. So it is only the turbulence of the water which keeps the oxygen getting dissolved easily in water. So similarly, there are several physico-chemical factors which affect the planktons. Now, on the basis of the salinity of water, the water bodies, they are classified into these 4 categories. Fresh water, where the salinity is 0.05 or less, and got 0.05 to 3% salinity, while saline water, which we call generally as marine water, has got 3 to 5%. Brine, when extremely saline water, this salinity. So, with this, some of the properties of water, I come to one of the important, very important parameter of the water, that is MPN. The bacteria most probably has MPN. Now, MPN, we know that it should be 0 in potable water. In any two consecutive sample of 100 milliliter, both the consecutive samples, they should not have even any.
Gunjan ma'am? Gunjan ma'am? I think connectivity is lost.
आई थिंक कनेक्टिविटी थोड़ी गड़बड़ हो रही है, बोला है मैंने, देख रहे होंगे।
Okay, okay, ma'am.
हेलो कविता, पल्लवी।
Yes, ma'am.
हाँ, वो थोड़ा सा वहाँ कनेक्टिविटी का प्रॉब्लम हो रहा है, तो अभी ऑफिस में जाके जुड़ रहा है। मैंने
ओके
पूजन मैडम को बोला है, तो टिकन जोड़ेगा, तो थोड़ा 5 मिनट के लिए हम लोग थोड़ा वो हो सकते हैं, है
हाँ,
ना?
अभी क्या ऑफिस से जोड़ रहा?
हाँ, ऑफिस से जोड़ने मैंने कहा है। टिकन टिकन को मैंने फोन कर दिया, गुंजन को भी बोला है, ऑफिस के नेट से कनेक्ट करेंगे सबको।
Okay, ma'am. Okay.
ठीक है, ओके।
I am sorry for the interruption. Meanwhile, we can discuss if any of the participants want to discuss anything regarding topic, they can.
Can I ask one question to for Dr. Sharma?
हाँ यार,
Is he still available?
या you
Yes,
can
ma'am.
ask, start.
Hi, hello, Dr. Sharma. Dr. S.S. Sharma.
Yeah.
Can
Sumna,
you hear
start your video also.
Okay.
Okay, ask question. Ask the question.
Hello.
Okay.
My question is there any proficiency body that provides competency requirement for identification of planktons?
And then
So your voice is not clear. Please.
Voice है ही नहीं.
Can I ask the question again? Thank you. First of all, I thank both of you, Dr. S.S. Sharma and Nandini Sharma, for providing a very nice lecture on planktons. My question. Hello?
Sunita, please mute. Okay, I mute. Okay.
Yeah, my question is that is there any available proficiency testing body or provider for assessing or the competency of the technician who can identify the planktons microscopically in the world?
Sir, your voice is not audible. Please come closer.
Okay.
No, I think that there are very few
Have
very
you
few taxonomists.
have you got my point?
Yeah.
Okay.
No, I don't think that there's anybody available, any organization available for such a broad spectrum of organisms. But there are individual groups.
क्या चल रहा, कुछ बोल रहे हैं क्या इनका?
नहीं सर, just discussion थोड़ी देर gap था तो.
But thank you, please continue.
Till the new connection it gets ready. So, Sumna, what are you doing there? क्या कर रही हो वहाँ?
I am a Canadian Association of Laboratory Accreditation. So I am a lead and technical assessor for ISO 17025 accredited labs all over Canada and abroad. As a ISO 17025 auditor.
नहीं, इधर नहीं सुनाई पड़ रहा है सुमना. ये इधर कुछ वो है.
I will connect with you later. I don't want to interrupt your talk. Actually, I am more interested in your talk. So I will ask my question to Dr. Sharma later. I will connect with him and Nandini ma'am too. I will connect with you guys later. Thank you so much.
Dr. Sumona, if you are still with us.
Yes, ma'am. Yes, ma'am.
Sharma was also stating that there is no such body that will determine a plankton species. But if you talk to an expert taxonomist on each group, they will be very happy to identify your species based on the characteristics that they can see and suggest whether your determination or identification of the species is right.
Yeah.
That's the thing.
Oh, yeah. I think there is a higher need because of, there should be a competency level to ensure that the microscopic identification are accurate and the technicians are competent. And for that, they have to pass maybe 2-3 studies, which are unknown samples, and they should be accurately identify the known plankton, phytoplanktons or zooplanktons.
Yes, but there is a certain degree of confidence.
Yes.
For instance, if you state that your species of Cladocera has been confirmed by Alexei Kotov in Russia, then you understand that it is correct. Because Kotov is an expert.
Yeah.
So that is the way it works with determination. For instance, if you are working with some species of cyanobacteria and you say that Komarek has confirmed the species for me, then you know that Komarek, Shiri Komarek from Czech Republic is an expert, and then you do not doubt that determination. But if you have a species and if you ask a young person whom nobody knows in the world, then there is a certain amount of doubt.
Yeah.
So that is, but there is no such thing. It is not like any lab which does these kind of tests and blind tests and all that. You go directly to the expert.
Yeah.
That is what we were talking to you yesterday about the virtual rotifer collaboratorium. So in these talks, if you send me your email, we'll include you. You will see that in these talks, the experts are there. And these experts will determine the speed. Okay, thank you. Thank you.
कविता शर्मा मैडम को अनम्यूट करो, वो म्यूट हो गई हैं।
ओके मैम, खुद म्यूट कर सकती हूँ क्योंकि मैंने किसी को म्यूट नहीं किया है आज।
अच्छा, तो फिर मैडम को बोलना।
मैम अनम्यूट हो जाइए। मैम अभी
नंदिनी
बोल
मैम,
रही है।
प्लीज अनम्यूट योरसेल्फ।
यस।
या ओके।
मैम जैसे हम लोग बहुत सारे बर्ड्स एंड बटरफ्लाई, वेबसाइट फॉर आइडेंटिफिकेशन, there is no website and sites for the identification for the planktons, no?
No, there is, like if you go, there are some very, very good websites for rotifers. But the problem is that it is difficult. It is difficult because there are characteristics which are very specific.
Okay.
And so many people are not aware. So I suggest that the best thing is that you take a good photograph. अब आपकी interest के ऊपर भी तो है ना. अगर आपको taxonomy में पूरा life dedicate करना है, वो बात दूसरी है. लेकिन if you just want to know the name of the species जो आप culture कर रहे हो,
okay,
confirmed identification के लिए you take a good photograph और एक expert को आप भेज दीजिए. अब मैं बताऊं आपको कि अगर रोटिफर में आप एक्सपर्ट्स ढूंढ रही हैं तो दुनिया में 5 होंगे. तो इस वजह से यू शुड बी अवेयर दैट कौन है एक्सपर्ट्स, किसको मैं भेजूं. तो हाँ, तो उस वजह से जो मैं कह रही थी वो वर्चुअल रोटिफर कोलैबोरेटोरियम, वहां पर हम लोग बात करते हैं. वहां पर एक एक्सपर्ट है ऑस्ट्रेलिया में रश शील, एक है ऑस्ट्रिया में क्रिश्चियन जेरसबेक, एक है बेल्जियम में हेनरिक सेगर्स, और एक आध है अमेरिका में सुसाना डिपाजी, बॉब वॉलेस एंड डॉक्टर शर्मा. तो अगर आप इन एक्सपर्ट्स को भेज देते हैं तो वो लोग आपको इजीली आइडेंटिफाई करके बड़े खुशी से भेजते हैं. उन कुछ चार्ज भी नहीं करते और कुछ कहते भी नहीं है. तो बस पूछने की बात है. लेकिन अगर आप इन एक्सपर्ट्स को भेजकर, अगर आपने अपने आर्टिकल में लिखा कि इन्होंने मेरे स्पीशीज को कंफर्म किया है, तो आपके रिव्यूअर्स नहीं पूछेंगे कि किसने कंफर्म किया है. डाउट नहीं होगा.
ओके, थैंक यू.
यही डिफरेंस है. आप कुछ कह रही हैं मैडम, सुनाई नहीं दे रहा.
हाँ मैडम, मैं ये पूछ रही थी, आप लोगों का जितना भी काम था प्लैंक्टॉन्स पर है, जो हम लोग ने अभी देखा, फोटोग्राफ्स बहुत ही सुंदर हैं. कौन सा कैमरा यूज किया है आपने, माइक्रोस्कोपिक कैमरा उसके लिए, फोटोग्राफी के लिए, कि कंप्यूटर पे जाके आपने क्लिक किया? व्हाट इज द टेक्निक बिहाइंड इट?
नहीं, टेक्निक नहीं. हमारे पास एक नाइकॉन का कैमरा है. नाइकॉन का NIU करके कंप्यूटर है और नाइकॉन का कैमरा है. लेकिन ये आजकल तो बच्चे लोग, हमारे स्टूडेंट्स और आपके स्टूडेंट्स भी सेलफोन से इतने अच्छे अच्छे फोटोज ले लेते हैं. है ना? हाँ, तो बहुत बहुत आराम से हो जाता है आजकल. तो बस उनके पास बहुत बहुत एबिलिटी है बच्चों के पास.
जी
और वो आराम से ले लेते हैं फोटो वगैरह। लेकिन प्रॉब्लम ये है कि अगर आप रोटिफर्स में पूछे तो ट्रोफाइल लेना है, क्लैडोसेरा के बारे में पूछेंगे तो डाइसेक्ट करना है ना। तो इस वजह से मैं ये सजेस्ट कर रही थी कि अगर आप किसी एक्सपर्ट को जानते हैं तो उनसे पूछ लीजिए। अब जो यहाँ पर हाइड्रा पे काम कर रहे हैं वो जानते हैं कि उनके फील्ड में एक्सपर्ट्स कौन है। इसी तरह से अगर आप जो क्लैडोसेरा पे काम करते हैं यहाँ इंडिया में, और या रोटिफर्स पे तो यहाँ पर आपको इंडिया में बीके शर्मा है, वो नॉर्थ शिलोंग में है।
ओके।
और वो क्लैडोसेरा और कोपे रोटिफर्स पे दोनों पे कर सकते हैं। कोपेपोड्स के लिए यहाँ पर इंडिया में एक थे डॉक्टर रंगा रेड्डी, लेकिन आजकल वो काम नहीं करते हैं। तो मेरे ख्याल से तो कोई और मेरे हिसाब से नहीं है, लेकिन अगर आपके आइडिया में कोई हो तो आप वहां से आइडेंटिफाई करा सकती है। हाँ, ये टॉक शुरू हो गया।
हाँ, यस सर।
यस
अनम्यूट कर लेंगे आपने आप।
ठीक है वो मार सर, एक मिनट बोल के
कैमरा भी ऑन कर लो।
ये रहा
हाँ, अभी दिख रहा है सर, एक बार बोल के देखिए, साउंड भी क्लियर हो जाए।
हाँ मैडम,
जी
मैं पढ़
सर।
रहा हूँ।
ओके सर, नाउ
हाँ. Now, I was talking about the most probable number of coliform bacteria, where I was saying that the potable water, it should not have any number of, or it should have 0 coliform bacteria. Now, we know in Chhattisgarh, most of the people, they take bath in ponds. So, I just determined the MPN number in the ponds as well as in the potable water, which the people, they are drinking in their houses. Now, I have taken 10 of the ponds, and on the left side, you will see the values. Now, you can see what is the unimaginable number of E. coli forms are there in the ponds. And what is interesting is that lakhs of people, they are taking bath in these ponds. And we should actually be very proud that how much resistant we Chhattisgarh people are, that still with bathing in these ponds so much highly contaminated with coliform bacteria or the fecal contamination, still we are surviving. So that thus we have a very great power or very high level of resistance towards this, the pathogen. Now, when I investigated the coliform number in the potable water also, it's from some 11 places from different parts of Raipur city. When I analyzed the MPN number, nowhere in none of the potable water I found MPN to be 0. And thus we are rather adopted or habituated to survive with this, drinking the contaminated water. Now I fear that in the present age of this, the bottled water, what will happen? Because our natural water all around us are highly contaminated, and we are taking now the bottled water. If by mistake we take bath in such water, or we take or drink such water which is there in municipal tap, then certainly we will, by that time, we will have lost our the resistance, and then there is more probability that we will fall ill to these bacteria. So it is very interesting that we are presently at least very much resistant towards these the pathogenic bacteria. Now, as I was talking, that Chhattisgarh is the state of ponds. So this is the number of a general idea about the number of water bodies in our state. Water bodies less than 2.5 hectare are almost 1,12,673. And thus, the ponds of different sizes, this is their number. So these figures, this show automatically that how much rich we are with the number of ponds. And unfortunately, now what is happening, that gradually we are losing these ponds. These are the surface storage water bodies. They were recharging, these ponds are recharging our groundwater. Now we have started taking out our groundwater. On the other hand, we have now started reclaiming these water bodies. So on the one hand, water bodies, they are decreasing. And on the other hand, without the groundwater recharge, we are extracting this groundwater. So that is why, this is the main reason that our water level, it is going down very rapid. Now, with this, I would like to go, I would like to show you views of some of the ponds of our state. Now, you see on the left side, a photograph is there where a toilet is there, and its fecal matter, it is falling just on this pond. And in this pond, the people, they are taking bath. We can imagine how much careless we are towards the health of our people. Now on the right side, you see the people, the buffalo, they are all bathing together in the same pond. This is the photograph of our, what we call as the Dudadari pond. And it is the condition almost of every pond in our state where the cattle and the people, they take bath together. And still we are surviving. Now, these are views of some of the ponds that all these ponds, they are all highly polluted, and so much polluted that you can see nothing, even the planktons, they are unable to grow in this pond. Now, you see these ponds that this is completely blue-green. So much these cyanobacteria, they are growing here. Now, it is very interesting that I have found ponds of several types with respect to growth of vegetation. Now, this is one example where no macrophyte it is growing, no Eichhornia, no Pistia, nothing, no macrophyte is growing, only the blue-green algae, they are growing. Now, why it is so? It is very interesting that the blue-green algae, they only are growing and other they are not growing, because blue-green algae, they have the capacity to the nitrogen fixation. So we can say this pond, it is having less of nitrogen. Due to less of nitrogen, the other plants, the macrophytes, they are unable to grow. And if you find any such pond where you find only blue-green algae growing, you can directly predict that it is abundance with other macronutrients, most importantly, the phosphate. Phosphate is required also by the planktons. So phosphate, it is a phosphate-rich pond, but it is poor in nitrogen. And in such pond, only the blue-green algae you will find growing. Now, these are some other ponds of Raipur city area. You can see this pond is covered almost with macrophytes. All these ponds, they are covered with macrophytes. These ponds then, as I have told, they are rich in these two major nutrients, the phosphate and nitrogen. Where the phosphate and nitrogen, it is more in concentration if it is receiving the sewage water. The sewage only is rich in both the nitrogen and phosphorus. Now, these are the views of the ponds within Raipur city area. And these ponds, they are no more in real terms the ponds. They are only sewage stabilization ponds. Now it is interesting that these ponds earlier, they were receiving natural water and their quality was good as far as human use was concerned. But now what has happened? We have erected concrete wall all around these ponds. So the source of natural water, it has been cut off. And these ponds, they are having water only in the form of sewage. So if sewage is stopped entering these ponds will go dry. And that is going on. And gradually, these ponds, they are being reclaimed, at least within the bigger city. Raipur city at one time was having more than 150 ponds again, and now it has got only some 50 or odd pond. So all other ponds, they have been reclaimed. So whatsoever the ponds remaining, they are all acting as the sewage stabilization ponds. These are some other ponds, again, of Raipur city area. You can see the condition, what miserable it is. Here you can see the growth of, again, the blue-green algae. Here the macrophytes are growing, and like that. Now, this is photograph of one of the largest water body, what we call the Vivekanand Sarovar, named after that great man. And you see what for the pond it is being used. You can see the disposal. Sorry. So I continue. Please continue. So you can see the disposal of this the waste matter into this the most revered pond. Now again, this is a pond where again it is the color is not so much clear, but it is again only blue-green. So what I am showing here is that we have two types of ponds in our city. Some of them are having only the macrophyte covering. Others, they have got only the blue-green algal coverings. So it is very important that we should analyze these ponds in detail. Why it is so that in some of the ponds, the macrophytes, they are choking the ponds, in other only the blue-green algae are growing. It requires some proper investigation. Now, this is an interesting photograph of some jelly-like mass. This is from a pond in Kanker city area. What I found was that if the fish spoilings, they come in contact with this jelly mass, they die immediately. So much toxic it is. So I was unable to know what is the cause, but I had seen that in the same pond, the fishes are there and this jelly mass is there. But the fishes, they keep distance from this jelly mass. Now, once I captured some fishes and put them over this jelly, and the fish spoilings, they died within a minute. So what it is, I was unable to, although I dissected it, observed it under microscope, but I was unable to know that what is the cause of toxicity of this jelly. Now, interestingly, in some of the ponds, you will find the color is not so much clear, but this is yellow color. It is covered with some yellow scum, this pond. And many of the ponds in Chhattisgarh, we find that they are covered totally with this yellow scum. We will think that it is some pollutant which is covering the pond. But when I brought the water and observed it under microscope, to my horror, I found that some organisms, they are moving. And on further observation, I saw that it is Euglena. Euglena hemichromata, the algae as well as the protozoan, what the both botanists and zoologists they call it. So this Euglena, it forms a scum over it, particularly during the night time or early morning hours. Now, as soon as the sun comes out, they generally go down due to being more mobile with photosynthesis. Now, another water body which requires some more investigation is what we call as the hot water body, or this the Tata Pani, the water body, where sulfur spring rather it is, where hot water it is coming. Now this is sulfurated, sulfur-rich water body, and it will be very interesting that the planktons of this water body, they are analyzed. You will get a gradient of temperature and sulfur in the water. At the point of origin, it is more than about 100 degrees Celsius in temperature, while as it flows down, the temperature, it gradually decreases. So it will be a very interesting study that with the temperature gradient, if we analyze the planktons there. Now, I found that generally the diatoms, they are more tolerant to temperature in this water body. So anyhow, but it requires some detailed study. So it is a challenge for us that we analyze the planktons of our state in these all the different types of water bodies, and particularly this hot water spring. So it is up to the students of zoology to take up this work. Now, this is again a very large dam that is totally covered with a fern, the Salvinia fern. No one is taking care of this. The entire sewage of that city, Narayanpur city, it is being diverted into this water body. And it is the result that it has become covered with this form. Now, this is another type of water body. What we see is that no pistia, no icornia, no salvinia, they are growing. What are growing are the Nilambo, Limnanthemum, and such type of species. Now, these are quite different types of water bodies. These are not receiving sewage, but they are receiving only the what we call as the washed sediment from the adjoining area. So this type of ponds, they can clearly be identified that they are non-sewage polluted ponds. So they will have some entirely different type of plankton. So similarly, now I was talking about Ratanpur city, which has got more than 120 ponds. And at some time, those ponds, they were being used either as the water source for drinking water or for bathing and all that. Now, the condition, it has deteriorated so much that probably only a very few of the ponds, they are being used as the bathing place. Now, when you go deep inside the villages, now here you can see a very clear water body, which is an oligotrophic water body. So it is fortunate that our village water bodies, they are still less polluted. Although in some of the villages you may find some pollution, but most of the water bodies in villages is still, they are less contaminated with the sewage. Now, a very interesting one. A pulse stable water body. What is the village named as Gidwa? Now you can see how many microphytes, how much microphytes, choking growth of macrophytes is there. Choking growth of several types of species. Now, as I have told, it has no pistia, no icornia, and so thus it is not sewage polluted pond. But this shocking growth of macrophytes, it indicates that it is polluted with the agricultural waste or the sediment which is coming into the pond from the surrounding. It is interesting, this pond is that such ponds, they attract a large variety as well as number of the birds species. We are going to declare, we have already declared this pond as a bird sanctuary. A large number of birds, the foreign birds, they congregate into this pond. Now, similarly, this is another a pond in a very high hilly area. Here also you can see no pistia and no icornia, only other macrophytes, non-sewage polluted pond. Now, these are some of our rivers. This is one of the lifeline of our Bastar region, the Indravati River. This is lifeline of Chhattisgarh, the Mahanadi River. These are still relatively, they are not so much contaminated as the rivers of UP and other such industrialized states are there. So we are fortunate. Now, I will talk a little about the some of the microbes I have observed in these water bodies. Now, you can see photographs of some of the Euglena species. It is interesting that you go for observing these organisms and you will be surprised that I have observed more than 50 species of Euglena in the water bodies of Chhattisgarh. Euglena, if you want to see them, you go to some dairy area and where the buffalo dung or cow dung, it is accumulating and water is there, you collect that water and you will be very much enjoy the presence of large number and species of Euglena. So still, we don't know how many species of Euglena we have in our state. Unfortunately, the student which has worked on this Euglena, the student could never publish this work. Almost more than 50 species of Euglena. And then these are the Euglena species, all these are. So these are, you can see how many species of Euglena. I have collected all these species from Chhattisgarh area only. Now, another genus is the Liposynchlis. Liposynchlis, although a small genus, but still we have got 4 to 5 species of Liposynchlis. And then another, a major species of the planktons is the Ficus. Ficus, again, 50 to 60 species I have collected. These are all different Ficus species from the water bodies of Chhattisgarh. So these two are the, and another one, this is the Trachylomonas. Trachylomonas also is a very large genus and large number of species. I suppose not than 60 to 70 species of Trachylomonas we can have in the ponds of our state. So, but this requires some detailed investigation, and I would say that it is a challenge to the students working on water bodies in our state. So, these are some of the protozoans I have observed in these ponds. I don't know much about the protozoans. I have taken their photographs only. So these are some of the rhizopods and other groups of protozoans in the water bodies of Chhattisgarh. So these are some of those protozoans. So what I would like to say, and then these are some amoebae and amoebae and some such genera in the water bodies. These are again the protozoans. This is Euglida hemichromata. And this is Vorticella. Actually, this I have got a video of this Vorticella. Very interesting to show how it feeds, but unfortunately, that video it is not running present. So, dear friends, what I would like to conclude that we have got a large number and variety of water bodies in our state with variable physico-chemical characters, and these are very rich places for working on the planktons, and a good work, very good work, several good works can be done on these water bodies. So at the end, thanks to you. If you have got any queries, if I can answer, I don't claim to be able to answer every question, but if I can answer, I will try to answer your query.
Thanks a lot, sir. Thanks a lot, sir, for such a very informative lecture. Now the session is open for discussion. Participant, please unmute yourself and ask the question if any.
Sir, I have one question.
Yeah.
Is there any regulatory requirement by the government of Raipur?
Pardon?
Is there any regulatory requirement
On
the planktons limit for certain ponds?
Regulatory requirement?
Yes, from the government of Raipur.
No. I won't be able to answer that question. Probably Dr. Sharma may be able to answer that question. So sorry, I am. Yeah.
Okay. Okay, but thank you very much. It was very
Dr.
nice.
Sharma, and yeah, I suppose Dr. Sharma is listening. He may be able to answer this question. Yeah.
Well, as far as I know, there is no regulatory system except Central Water Board. Commission can make some preliminary study and report the status of the water body based on the E. coli counts, coliform counts, and BOD, COD, BOD, and that. So that information is missing.
Yeah.
You cannot classify.
Yeah, for drinking water regulation, there is regulatory requirement that coliform E. coli should be 0. But I am not sure about because you guys are experts, so I was just asking if there is any regulatory requirement
Yes,
for
but
to
don't think that
indicate pollutants,
yes,
like how much level of phytoplankton or zooplankton should be. There should be limit for
no,
certain pond, or there
no,
isn't any. Okay.
no, there is no limit on the phytoplankton or zooplankton. The importance is of the bacteria and of the nutrients, and that is to be defined. I don't think that water from these ponds are used for drinking water purposes. But the
No,
poor people obviously live over there, so there is no option for them. But,
I know.
but I don't think that it is used for drinking water. For drinking water, I'm sure they get their water from some reservoir or from some river. So the water quality over there may be different. But there is one point, if I have time, I don't know if I have time 2 or 3 minutes to explain one case, but
Yes,
I can.
you can explain, ma'am.
Yes,
Okay.
thank you. So in this case, what happened was that Edmondson was living on the side of Lake Washington in the 1950s. And Lake Washington was extremely contaminated, like these water bodies, very, very polluted. So the first thing that he did was to develop a very good sewage treatment plant.
Yes, yeah.
So if you want to protect your water, you only have to first invest in sewage treatment. There is no other way. There is no other way, because if sewage is entering the water, it is impossible to keep it clean. Once you control the sewage in the water, after that you can have lake biomanipulation and management strategies. So there is
then it is regulated. Yeah. Otherwise,
so there is a
no
very
way.
and Edmondson was able to develop the sewage treatment plant facility in Lake Washington, and based on that he was able to absolutely make Lake Washington from green to blue.
Yeah, I know.
So that is what is needed. But it is not possible because the population is very high. There are a lot of socio-economic problems. So things like that. And
How
yeah.
much government is ready to spend? All
Yes.
depends on government. It is because it
Yeah.
No, not
budget.
only
Actually, awareness is important. Awareness is necessary for
Awareness
the
is very
villagers.
important. Yes.
Yeah. We have all the rules about
we know everything.
quality of the effluent to be allowed into water bodies. All
No,
the
it's
rules we have got, but not in enforcement actually.
not
And yeah,
government is not spending money.
we are rather allowing our people to become more and more resistant towards this pollutant. Yeah.
We need an awareness, because for drinking water there is a municipal connections, but
Yeah.
awareness is necessary. They don't want to move towards that. It is easy to take pond water from their, it is the nearest for their house, so they take this.
Thank you so much, sir. Thank you.
Thank you. We have a system of social service. So what we do is that young people are forced to spend 480 hours of their career, of their BSc course, to do some social service. So if you have such a program, you can take the young people and teach young students, and these students can take the information in the form of charts or something to the community. Awareness, you have to create awareness for the people.
Okay.
Thank you.
Thank you, sir.
So thank to all the listeners, particularly to my very, very, very old student Sumana, who is still working even at 2:30 o'clock in the night in Canada. So I am more thankful to her rather. Yeah, thank you.
Thanks a lot, sir. Now I invite Mr. Satish Samteke, Assistant Professor Geology, to give vote of thanks to Nayak, sir.
Thank you, ma'am. A very good afternoon to our speaker, Dr. Nayak sir, seniors, dignitaries, and all the participants present in the second session of the second day international webinar on plankton biology. I'm here to present the vote of thanks. Dr. Nayak sir delivered the lecture on the topic water quality and planktons in Chhattisgarh. He discussed how the plankton population has been affected due to contamination in the various water bodies of Chhattisgarh, especially the ponds. He discussed how the ponds and potable waters have been causing a scarcity of water as we have been continuously encroaching the ponds and uncontrolled use of groundwaters. He also told us about how has been able to identify various species of euglenas and other protozoans in different water bodies of Chhattisgarh. And he also told us about how the micronutrients affects various populations of different planktons in the name of nitrogens and phosphorus. On behalf of the Department of Zoology and the entire family of Government LPG College, I am grateful to convey my gratitude to Dr. Sir, knowledgeable and informative lecture. Thank you, sir.
So thank you all. Thank you.
Thank you very much, sir.
Thanks a lot, Satish. This was the last lecture of the technical session, and all the lectures given by the eminent speakers are very informative and will surely benefit to all the participants, especially the young researchers working in the area of plankton. I again extend my gratitude to all the speakers and thanks to the participants. This technical session will be followed by the valedictory function, which will be conducted by Mrs. Gunjan Ojha, Assistant Professor, Department of Zoology. So I welcome Ojha Madam to proceed the webinar. Ojha ma'am.
Thank you, ma'am.
Welcome, ma'am.
Good afternoon, everybody. I, Mrs. Gunjan Ojha, take this opportunity to welcome each one of you to the valedictory function. Today, we have our keynote speakers, Dr. S.S. Sharma and Dr. Nandini Sharma from University of Mexico with us on this platform. We have our guest speaker, Dr. Vimal Kanungo from Chhattisgarh College. We have Dr. M.L. Nayak, ex-professor of Ravi Shankar University and present member of Biodiversity Department of Chhattisgarh. Dr. Surendra from MECS Agarkar University, Pune. We all know that conferences and seminars are live wires of all academics. These are platforms from where many academicians from worldwide locations share their innovations and views. In this series, we have one more lecture by Dr. Surendra, for which I invite Dr. Seema Gupta, Professor and HOD of Zoology Department, Nagarjuna Science College, to introduce our guest speaker, Dr. Surendra.
Just a minute, ma'am. सर पहले ज्वाइन कर लें.
सुरेंद्र सर को ज्वाइन कर लेने दीजिए उसके बाद.
I have joined a few minutes back.
Okay,
yes,
sir, please कैमरा ऑन कर लीजिए आपका. Yes,
yes, sir.
Good afternoon, sir.
Welcome, sir.
Welcome, sir.
Good afternoon to all. Am I audible?
Yes.
Yes, ma'am.
But your video is not. Now it is not audible, ma'am. Gupta, ma'am.
सीमा गुप्ता मैडम, आपकी आवाज नहीं आ रही है.
Okay. Am I audible?
Yes. हाँ आ रही है आवाज. आप बोल सकते हैं.
वीडियो भी चालू है. First of all, On behalf of organizing committee, I extend my warm welcome to all the dignitaries and participants of this 2 days international webinar. Today, we feel great pleasure to have an eminent scientist and renowned person among us in this virtual platform, Dr. Ghas Kadvi. Very briefly, I would like to narrate some of the achievements of Dr. Ghas Kadvi. Dr. Suren Ghas Kadvi did his MSc in 1978, MPhil in 1980, and PhD in 1984 from the University of Pune, Maharashtra. He has been associated with Developmental Biology Group at Agarkar Research Institute, ARI, Pune, an autonomous institute of Department of Science and Technology, Government of India since 1985. His main research interests are cell signaling during pattern formation, evolution of developmental mechanisms, and stem cell biology. He has used a variety of model systems such as chicken and frog embryo, sponges, hydra, and human mesenchymal and embryonic stem cell in his work. Over the past 2 decades, he has reintroduced hydra as a model system for teaching and research in India. His research has been funded by DST, DBT, CST,
मैम आपकी आवाज और आप नहीं दिख रहे। हेलो गुंजन ओझा मैम, प्लीज हेल्प मैम। मैम नहीं दिख रही।
Yes, ma'am.
या या
Am I audible?
Yes.
Dr. Ghas Kadvi has published his work in reputed peer-reviewed journals and has several national and international collaborations. He has delivered many talks in national and international meetings and students' camps and contribute to postgraduate teaching in many institutes in and outside Pune. Dr. Ghas Kadvi has been associated with several scientific organizations in India. He is currently the president of Indian Society of Cell Biology, is a past president of Indian Society of Developmental Biologists, and is an elected fellow of National Academy of Sciences, India, and Maharashtra Academy of Sciences. Without taking much time, I request Dr. Ghas Kadvi to deliver his talk and enlighten our participants. Thank you. Thank you.
Thank you. Thank you very much for the kind introduction. So what I have decided to talk today is about Hydra, a model system or research organism that I've been using for the past 20 years. And to tell you how we have tried to use it to study evolution of cell signaling, cell signaling. I hope you can see my screen well and you can hear me also.
Yes, sir.
Okay. So Hydra is an organism, as you see in this picture, which is a very simple cylindrical organism, 1.5 centimeters long, and it has tentacles on one side, which surrounds the mouth, and that is called as the oral end of the Hydra, and the other end is known as the aboral end. Hydra usually reproduces by budding, and it so happens that the word Hydra was mentioned in Greek mythology, as you can see here. And in this case, there is a multi-headed monster in Greek mythology called Hydra. And you can see King Hercules trying to kill the Hydra. So unfortunately, Hydra picks up its name from this particular monster, although there is nothing monstrous about Hydra as far as I can think. So if you take a vertical cut in the head of Hydra, a little bit of vertical cut with a blade, then that Hydra grows two heads. If you take two cuts perpendicular to each other, it grows into four heads. And that is why it can become multi-headed. And that's how it has picked up the name Hydra from Greek mythology. So just to keep things in perspective, I'm sure you are all aware of this uh, phylogenetic tree. What I would like you to notice here is that the sponges or the poriferans evolved somewhere here, as you can see, and that is the first phylum of the multicellular organisms. And then a few million years after that, the cnidarians or the cylindrates evolved. Hydra belongs to the phylum Coelenterata or Cnidaria. What I would like you to specifically notice is that the nerve cells or the neurons make their appearance for the first time after the evolution of sponges. That means sponges do not have two neurons, but Hydra has two nerve cells. And these nerve cells make it possible for the Hydra to have an organized nervous system. This nervous system is present in Hydra in a very simple form, in the form of a nerve net. But what is very, very important from an evolutionary point of view is that because of an organized nervous system, Hydra can actually go for active feeding. As you know, sponges feed passively. As food particles come through the channels, they pick them up through phagocytosis. But Hydra, as it has an organized nervous system, it can catch its prey, put it in its mouth, and it can go for active feeding. So that is what considered to be one of the very major steps in animal evolution, wherein an organism can sense the prey, paralyzes the prey, and puts in its mouth. So that's a very important evolutionary advantage that Hydra had. And one of the reasons why people use Hydra to study biological features is because of the fact that it is the first organism with an organized nervous system. So Hydra was brought to science or recognized in science by a scientist called Abraham Tremblay, and he's shown on the left of the slide. On the right top of the slide, you can see Tremblay showing some aquatic organisms to certain students. They were from the Royal Flamingy, and we have this painting available from Tremblay's monograph. On the right-hand side, in the figure, bottom figure, you can see some Hydra floating upside down, which Tremblay brought to the lab. Tremblay was actually a a mathematician interested in studying infinity. But in his spare time, he would go and watch aquatic insects. On one occasion, as he was watching insects, he found some strange floating white tubes in water and brought them to the lab. And that's how we came to know about this organism called Hydra. Tremblay did not just stop at bringing the organisms to the lab, but he actually carried out experiments with them. So from his monograph that was published in 1744, Tremblay says that it was on 25th November 1740 that I cut the first polyp. So what he did was that he took Hydra polyp and cut it into two with a sharp blade. And he found that the two pieces regenerated fully in a few days. So this was the first demonstration of animal regeneration in the laboratory by a scientist. And it caught the imagination of people. And Tremblay did not only stop at working with this organism, doing experiments, but he widely, told scientists about his work. Not only that, he actually posted Hydra in water through the postal system in the 18th century to different labs in Europe. And this was for the first time that a live organism was actually, aquatic organism was actually brought to the laboratory, maintained in the laboratory, and was experimented upon. It was a kind of, before that, only terrestrial organisms were kept in the lab, like insects and rats and mice and so on, and chickens, but never an aquatic organism. So it caught the imagination of people that time. And there were many people who actually traveled to Tremblay's lab to see what they called as Tremblay's polyp. And it became a rage. And there was even a special supplement by a naturalist painter in the 1740s to show tremulous polyps and dancing human figures. So you can imagine that many people, although they were not interested in science, also traveled to tremulous lab just to see the polyp. And this is considered to be a very important stage in our marine biology. In fact, it was the Tremblay effect or the birth of marine zoology. So until that time, marine or aquatic organisms were not brought. I might caution you here that Hydra is actually a freshwater organism. It is not found in seawater. It cannot tolerate that kind of salt. So these are the live Hydra in my laboratory, which we have been maintaining for the past 23 years. So it was in year 2000 that I collected my first Hydra polyp from a pond in the University of Pune campus. And we have all the clones or the progeny of the same individual polyp for the last 23 years in the lab. So this is one of the species of Hydra we find in India. It is brownish looking, so we call it brown Hydra. And taxonomically, it is identified as Hydra vulgaris. There is another species of Hydra we find in India, and that is the green Hydra, which is Chlorohydra viridissima. So there are two species of Hydra that we commonly find in India. We do our work mostly on the brown Hydra because we don't want the contamination from chlorella in the green Hydra. So these Hydra are green because they have chlorella as endosymbionts. Okay. So these are the two types of species that you see in India. Just to tell you a little bit about the structure of Hydra, you can see here on the left-hand side an entire Hydra which shows an oral aboral axis and a radial symmetry like a starfish. The oral end has a conical structure called hypostome, and on which the mouth is situated. This hypostome is surrounded by a number of tentacles. Then comes the gastric region, and at the base is the foot or the peduncle region followed by foot. In the Indian Hydra, you don't get this peduncle or stalk-like structure, but only the foot is present. In the middle, entire body of the Hydra is called as the gastric region. At the lower one-third end of the gastric region, Hydra actually develops buds. So Hydra usually reproduces asexually by budding. But if need be, if conditions are favorable for sexual reproduction, it can actually go for sexual reproduction also, although the latter, sexual reproduction, is very, very rare. I will come to that a little later. So if you take a cross-section of Hydra, you will see that there are two layers of cells, the ectoderm and the endoderm. So unlike us, Hydra is a diploblast. It has only ectoderm and endoderm separated by a modified basement membrane called mesoglia. Hydra has about 20 to 25 different kinds of cells, which can include the stinging cells for nematocytes, which are present only in the cnidarians. Then it has the nematoblasts, which are the precursors of stem cells, and you have the interspecific stem cells. Then the Hydra has neurons, the sensory neurons, and the neurons. It has gland cells, which secrete the digestive enzymes, and the food is digested outside in the gastric cavity. So there are about 20-25 different kinds of cells in Hydra. Unlike in our case, where the complexity is much more, and we have about 200 different kinds of cells. So these are the various structures. The entire Hydra is made up of about 100,000 cells, 1 lakh cells, while we are made up of trillions of cells, and probably an equal number of microbes are present in our body. So this is the relatively simple structure of Hydra. Now, people have carried out very careful analysis of how Hydra cellular dynamics happens. So what they did was they labeled cells at different positions in the Hydra body, and they found that actually Hydra cells undergo mitosis, proliferation, continuously in the middle of the body column here. And then if you look at the red lines and the days mentioned there, you will see that the cells proliferate and migrate toward the two extremities of the body, either towards the hypostome or towards the basal disc. And some of the cells, of course, end up in the buds. So it so happens that about 80% of the cells of Hydra are sloughed off from the two extremities. They undergo apoptosis or programmed cell there and are sloughed off from the two extremities, while the remaining cells go into the bud. Now, what this tells us is that you will notice here at the hypostome 20 days mentioned, and here also at the basal disc 20 days. So in about 20 days, the cell of the Hydra is actually undergoes apoptosis and is sloughed off or thrown out of the column. So at any given point in time, any cell in the body of Hydra is not more than 20 days old. And therefore, Hydra is potentially an immortal organism. It does not age. The cells age and are thrown away, but Hydra defies aging and it does not show aging. Now, you will also must have noticed that, as I said, that cells undergo cell proliferation, and as they migrate towards the two extremities of the body, they also undergo cell differentiation and carry out different functions. The cells carry out different functions in the body. So an adult Hydra shows cell proliferation, cell differentiation, cell movement, cell adhesion, and cell death. So these are the characteristics that we see in vertebrate embryo. So actually an adult Hydra is like a vertebrate embryo. It is a perpetual embryo wherein developmental biologists or embryologists can see or study many things that are present in Hydra. Now, what you will also notice in this figure is that some of the cells are shown in blue, while most of the cells are in yellow. So the yellow cells are the ectodermal epithelial cells and the endodermal epithelial cells. Blue cells are also endodermal epithelial and ectodermal epithelial, but the blue cells are what are known as terminally differentiated. That means they undergo death immediately. And these blue parts that you see in Hydra are the ones which are never able to. Sorry?
Oh, ये कान में लग.
Is somebody asking a question or something? Hello?
Now it's okay, sir.
Okay, okay.
It's some
So
disturbance.
if others can mute, it will be very nice.
Yes, sir. I muted
Yeah.
all.
Right. Okay. Sorry about that. So these blue cells are the ones which are terminally differentiated. That means they cannot undergo mitosis and they are sloughed off. While the cells here, the yellow cells that you see, undergo mitosis. That means they self-renew. As I said, in the middle of the body column, cells continuously proliferate and move towards the two extremities. So it is a very interesting phenomenon where the epithelial cells work as an epithelium, but they can also undergo mitosis. So you might remember that in our body, if cells differentiate, they exit mitosis. They cannot proliferate. But here in Hydra, it is a very peculiar situation wherein the epithelial cells carry out the function of epithelia, but they also carry out the functions of stem cells at the same time. And why say Hydra is capable of regenerating or replacing cells continuously over its life, over and over again, is because of the stem cells that it has. So Hydra is basically three stem cells populations, and the epithelial stem cell population, the ectodermal epithelial cells and the endodermal epithelial cells are shown in yellow at the top. And these are the epithelial cells which are also stem cells. So they can undergo mitosis. They self-renew in 3 to 4 days. And when they terminally differentiate, they either end up in tentacles or basal disc, as shown in the figure on the left, and then they undergo death. But these blue cells cannot undergo mitosis. So the yellow cells are the ones which continuously replace the ectodermal and endodermal epithelial layers. However, I mentioned that other than the epithelia, there are many different kinds of neurons, nematocytes, gland cells, and if need be, Hydra can go for sexual reproduction also, so it is to produce gametes. So all these other cells come from a third stem cell population, which are known as interstitial cells or eye cells for short. And you can see it at the right bottom of this figure. The interstitial cells divide fairly fast in 1.5 days. They double their population because they have to give rise to a large number of differentiated cells. And you can see here on the right of the bottom figure is that the precursor cells give rise to different kinds of neurons, They can give rise to 4 kinds of nematocytes, the gland cells and the mucus cells. And if need be, they can also form the egg and the sperm. So they are truly multipotent in the sense they can give rise to all kinds of cells other than epithelial cells. So there are 3 distinct stem cell populations, just to repeat what I said earlier. First one is the ectodermal epithelial stem cell population. Second one is the endodermal epithelial stem cell population. And the third one is the interstitial cells, which give rise to 15, 20 different kinds of cells. And as I said, they can give rise to gametes also. Now, in this case, some species of Hydra, it's very difficult for Hydra to go for sexual reproduction in the lab because Hydra prefers asexual reproduction. However, if conditions become unfavorable, for example, heat shock or cold shock, or they are not fed properly, starvation, they can lead to sexual reproduction. There are some species of Hydra which are, dioecious. They can produce both hermaphrodites, they can produce both eggs and sperm, but there are some other species which have male polyps and female polyps. So both kinds of reproduction is observed. But sexual reproduction, as I said, is very, very rare. And unless conditions become unfavorable, Hydra doesn't spend energy to form the gametes. And once the gametes are formed, the fertilization is external and the embryo growth also happens outside the body of the Hydra. The other feature, which is very, very interesting for biologists and generally to human beings, is the Hydra's spectacular ability of regeneration. So what I show here is this experiment was done in the lab wherein we took a Hydra and cut into 3 pieces. You can see that the middle piece is here. So the head piece, which has lost its foot, regenerates the foot in about 3 days. The tail piece regenerates the head in about 3 days. And the middle piece also regenerates both the head and the tail and the foot in about 5 days. But this is fantastic, and not only 3 pieces, but people have carried out regeneration with many pieces of Hydra, and each and every piece of Hydra regenerates into an entire Hydra. Now, let us see a little bit more details about the capacity of Hydra to regenerate. So, before going to that, let me explain that even if you cut Hydra into very tiny pieces, every piece will regenerate into a new Hydra. The only exception is the head piece with tentacles and the foot cannot regenerate. Okay, all the other parts of the body can regenerate. Not only a small piece of Hydra, but people have actually disaggregated Hydra cells by using chelating agents like KDTA and enzymes like trypsin, and even as a small cell pellet of Hydra. The pellet of cells from Hydra can regenerate into an entire organism. So it is a tremendous capacity of regeneration, even more than planaria. You may know that you can cut a planarian into 256 pieces, and each one of them will give rise or regenerate into a new planarian. In case of Hydra, that is even more, because only simple cells of Hydra can also regenerate into a new Hydra. Okay, I'll just stop here for a minute and see whether you are with me. Have you understood about Hydra?
Yes, sir.
Are there any questions at this stage? I don't mind taking them now or at the end, whatever.
I have one question, please. What is the food you give for Hydra?
I can't hear you properly. Can you be a little louder?
Yeah. What type of food you give to Hydra?
Okay. Can you just identify yourself?
I am Dr. Sharma.
Okay. Dr. Sharma, okay. That's an interesting question. For lack of time, I didn't explain that, but it's a very good question. So when we maintain Hydra in the lab, we feed them with Artemia larvae. Usually in the nature, they feed on Cyclops and Daphnia and so on, and they can also survive at temperatures over 40 degrees centigrade. However, in the lab, because the same procedure or protocol is used all over the world, we all feed Hydra with Artemia larvae. So we bring Artemia cysts and hatch them out, and the larvae can be fed to the Hydra. Hydra eats only live food. It doesn't eat dead food. The food has to float around and the tentacles have to sense that. So we feed that, and we maintain it at 18 degrees centigrade in the lab, and with a 12-hour light and dark cycle. So that is how it is maintained all over the world, and we also do that. You can feed them more, and then you can get more birds. So you can actually control the number of hydra in the lab by changing the feeding amount of feed that you provide. Does that answer your question, Dr. Sarma?
Yes, I have one more question, but I have read
Yes,
we have been maintaining Hydra 2 in our laboratory. We have some publications on that too, but we don't work on the genetics, but we work on the ecology. And one Hydra, as you said correctly, is almost immortal. But I read about the Hydra when I was working on that. I'm still working on that in the laboratory. That error accumulation theory says that Hydra can die after 1,000 years, even if you maintain the most ideal conditions. I don't know about that because I don't work on genetics, but this one.
No. That's a very interesting question and comment that you have made. So let me elaborate a little bit for others here. That Hydra is potentially considered to be immortal, and there are several theories. But if Hydra goes for sexual reproduction again and again, then it has been shown that they can die a little faster. However, as Dr. Sarma mentioned, that people believe that it can live for thousands of years. In fact, there was a paper in Nature about 3 to 4 years back, wherein those scientists had developed an algorithm to find out the potential longevity of different plants and animals. And according to that algorithm, a hydra should be able to live at least for 10,000 years. However, whether it is 10,000 or 1,000, nobody has been able to check that, simply for the reason that hydra outlives all of us. But there have been some studies on the telomere length and telomerase in hydra, but they have not provided us with answers here. So for us, it is potentially immortal. People have been given PhD project with a single hydra and follow it up for its longevity, and they had to change the PhD problem simply because the hydra refused to die. So it is potentially immortal, but I guess every organism has to die sometimes. But it is impossible to confirm whether a hydra would live for 1,000 years and so on. I'm sure none of us would be around by then. Okay. Shall I go ahead now? Or any other questions? If there are no other questions, I'll go ahead. May I go ahead?
Yes, sir, please.
Okay. Okay. So let me come to, I'll just like to give you a flavor of what we do in Akarka Research Institute, what we have been doing for the past 22 years. And these are some of the major areas. Of course, I'm not going to go into that. I'm also not going to too much of technical, jargon while presenting our work. But our main interest has been twofold. One is we are looking for pattern-forming genes in hydra. And while we did that, we mainly concentrated on molecules which are important in cell signaling. And the second is characterization of DNA repair genes for hydra. So not much is done. Actually, nothing is done about DNA repair in hydra. And we started this about 10, 15 years back. And now we know that it has all the xeroderma pigmentosum genes. It has many other genes that participate in DNA repair. And in fact, the genes are not only structurally conserved, but they are also functionally conserved. So today I'm not going to discuss the DNA repair genes, but I'll concentrate more on the cell signaling molecules. We have also looked at crosstalk between different signaling pathways in hydra, the effects of UV irradiation, the role of autophagy, and the characterization of hydra microbiome. These have been done either by our lab or in collaboration with others. But today what I will do is to concentrate on the first aspect, and especially on this molecule called noggin and this other molecule called gremlin. I'll just explain to you what we do, just give you an idea as to what kind of experiments we do and how it is important for understanding what I mentioned as evolutionary developmental biology. So evolutionary developmental biology, or EVO-DEVO for short, actually studies the evolution of developmental mechanisms or developmental phenomena. And hydra, since it is one of the simplest organisms and shows many embryonic characters, while in an adult stage, we were interested in finding out how it does that. The other reason is, I will come to, so we know that cell-cell communication is very important for multicellular organisms because multicellularity itself arose for the division of labor, wherein different cells carry out different functions in the body of an organism so that the organism can survive and reproduce effectively. So we know that there are very limited or relatively small number of conserved signaling pathways uh, through which the cells talk to each other in any animal. And these are the TGF beta, Wnt, and so on, these different pathways. So what we decided to do to begin with was because of our interest in nervous system formation. Can people keep quiet, please? Okay. So Hydra is believed to have evolved several million years ago. And as I mentioned earlier, it is the first organism to have an organized nervous system. Since our lab was interested in how nervous system developed, we looked at Hydra at some point. Before 2000, I used to work on frog and chicken embryos. But because we wanted to ask them interesting questions, Hydra seemed to be a better organism to use. So let me explain what I mean by neural induction or formation of the nervous system. This is the cartoon of a developing frog embryo, and many of you will be aware of this. This is, so what you have is the early embryo, okay? And then you have the prospective ectoderm here, epithelial ectoderm here. The endoderm is here. And because of the interaction between the prospective endoderm and prospective ectoderm, you get formation of the mesoderm in what is known as the marginal zone. Now, on the dorsal side of the embryo, you have a group of cells which we know as the Spearman-Malmgold organizer. So if this group of cells is transplanted on the ventral side of another embryo, we get duplication of axis. The work that Mangold carried out and for which Spearman got the Nobel Prize in 1928. So what happens actually is that in the entire early embryo, the BMP pathway is the default pathway. That means it is active in all the cells. BMP stands for bone morphogenetic protein pathway, and it belongs to the TGF beta family of cell signaling molecules. Now, what happens is, in this Spearman's organizer, cells of the Spearman's organizer secrete certain molecules, which are shown here, pyridine, noggin, polystyrene. You need not remember the molecules. I mean, it's not important. But these are all inhibitors of the BMP pathway. And these Spearman's organizer cells secrete the BMP inhibitors. And because of inhibition of the BMP pathway, in the ectodermal region, you get formation of the neural ectoderm. And in the endodermal region, you get the formation of the dorsal structures. And because of these, the mesoderm itself is divided into dorsal, intermediate, and ventral mesoderm. So since this is required for formation of the nervous system, we decided to look if Hydra has the noggin gene. That's where we started. Noggin actually means head in colloquial English, and therefore we thought that we should look for noggin in Hydra. So this was the reason why we started looking at it. Or none of these inhibitors of BMP were reported when we started this one. And it so happened that we concentrated on noggin, and it turned out to be quite exciting work. So initially, we used, Xenopus molecular probes from frog embryos to see whether Hydra mRNA is present in, noggin mRNA is present in Hydra. And it was in 2001 that we actually detected that. But these experiments were not very clean experiments because we didn't use Hydra probes for in situ hybridization. Antisense RNA was used from Xenopus, antisense noggin RNA, and it was used to detect Hydra noggin in the Hydra body itself. So it was not a very clean experiment, but even then we could detect noggin. And you can see that actually noggin is expressed when tentacles start developing in the bud. So these are the different stages of the bud of Hydra. Even in the adult Hydra, you can see that noggin is expressed at the base of the tentacles. Now, this paper was largely ignored at that time. And Partially it was correct also because it was not a clean experiment, as I mentioned. We used frog probe. But then Hans Meinhardt, who did a lot of work on mathematical modeling of pattern formation or formation of the organizer, actually saw this study. He got interested and he cited the paper in one of his reviews in Nature Neurosciences. And then somehow it was a kind of indication of this finding. And then we decided to look more seriously at noggin. Now, when we looked at, by using simple bioinformatic techniques, when we looked at the reduced amino acid sequence of noggin in Hydra, we found that it is quite similar to Gallus means chick, frog, human, and zebrafish noggin. You may notice here that we have labeled Hydra Palmatohydra oligactis here, but later on we have ourselves carried out molecular taxonomy of Hydra, and it turns out that it is actually Hydra vulgaris. So later on we have corrected the nomenclature of this Hydra. But what you see here is many of the amino acids sequences, many of the amino acid residues are conserved right from Hydra, which is a very, very simple organism believed to have evolved millions of years ago, up to humans here. You can see the similarity. And also the 7 cysteine residues, which are shown in blue, which are very, very important for the function of Hydra, are also conserved right from Nidarians to the Homo sapiens. So this was very encouraging for us. We were very, very excited about this and went further with some simple bioinformatics and found that the 3-dimensional structure of Hydra, which is shown in D here, is also very similar to human noggin, frog noggin, then sea urchin noggin, and so on. So there are some subtle differences there in the loops, but I'll not go into that. But overall, if you look at this, the Hydra noggin looks very, very similar to the human noggin or the vertebrate noggin. And this was very exciting for us. And we thought that Hydra noggin may play a role somewhere in the early nervous system formation. But this was only as far as the structure was concerned. But we also wanted to find out whether Hydra noggin has been functionally conserved. And for that, I collaborated with a scientist called Makoto Asashima, whom you see here with me in the Assi Ghat of Varanasi, on the Ganges. And Makoto Asashima is a frog embryologist. And what we decided to do with Makoto is that we decided to inject Hydra messenger RNA for noggin into xenopus embryos. Now, the reason behind designing the experiment was the following. And my earlier work in frog and chick embryology helped me think of this experiment. So let me come back to this cartoon that I have shown you. As I told you, in the dorsal side of the embryo, the cells of the Spearman's organizer secrete BMP inhibitors like chordin, noggin, follistatin, and they induce the nervous system in the dorsal side. Now, what people know from the experiments in xenopus is 2 important experiments they do. If you overexpress, so if you increase the expression of noggin, chordin, follistatin in frog with its own gene, then you get twin embryos, like the Spearman-Mangold experiment. That means excess BMP inhibition is capable of inducing a double head. Okay, that is the experiment, one of the experiments that is already known to the embryologists. Excuse me. So what we decided to do was that inject Hydra noggin mRNA into the Spearman's organizer and see whether we get a phenotype. And as you can see here, these are the controls, which are uninjected embryos, and they have led to the formation of the tadpole. In the middle, you see that Hydra noggin mRNA has been injected, and in 30 out of 30, 100% embryos, you get duplication of the axis. That means a new embryo is formed. And this is the positive control, wherein xenopus noggin has been overexpressed, and there also, as expected, we get in 100% duplication of axis. So this was very exciting for us that Hydra noggin is not only structurally conserved at the level of the amino acids, but it can also function in a vertebrate embryo, which shows that it is functionally conserved up to vertebrates. But that was okay, and we wanted to further confirm the results that Hydra noggin is actually functionally conserved. So we did another experiment. And to explain that experiment, let me give you a background. This is a picture from Gilbert's book on developmental biology. What you see in the middle here is a normal tadpole of xenopus. Okay, and if you overexpress noggin or chordin here, then these embryos tend to become dorsalized. That means they develop more dorsal structures than ventral structures, which is visible here through the high pigmentation. On the other hand, developmental biologists know since the 60s is that if you irradiate the early frog embryo with UV, ultraviolet radiation, then they do not form any dorsal structures, but they form only ventral structures. So they become what is called as ventralized. With high noggin, they become dorsalized. With UV, they become ventralized. So we know that these embryos do not develop any dorsal structures. So we decided to do an experiment with Asashima, is that you irradiate the frog embryo with UV first, and then inject Hydra noggin mRNA, and to see whether it can rescue the embryos from the effects of UV. And that is exactly what happens. So briefly, these are the master controls, which are uninjected, and you can see normal tadpoles here. However, if you irradiate the early frog embryo with UV, you get ventralized embryos, as you can see at the bottom, and you get very tiny embryos. But when we inject Hydra noggin or Xenopus noggin, along with UV radiation, then we get some rescue of phenotype, which shows that Hydra noggin is capable of carrying out the function of Xenopus noggin and rescues the embryo from the effects of UV. The only difference here was that the Xenopus noggin that we required for rescue is much lower, and the concentration of Hydra is much more. So it needed almost 10 times more concentration, and we believe that it is probably because of many different proteins that participate, which may be different in Hydra and frog. But it clearly shows that the noggin gene that evolved very early in development in Hydra, which was responsible for the formation of neurons, is actually conserved throughout evolution and is present in vertebrates. In our case also, noggin is extremely important in the development of nervous system and the brain. And we confirmed that, I will not go into details of these experiments, but we confirmed that the effects of Hydra noggin a messenger RNA in frog embryos is indeed because of inhibition of the BMP pathway. So the mechanism is also identical, and that showed us that Hydra noggin is conserved up to vertebrates at the structural as well as at the functional level. We also discovered recently, relatively recently, another molecule from Hydra, and that is gremlin, which is also a BMP inhibitor. And you can see here the three-dimensional structure of gremlin right from Hydra to humans. These are various species here. You may not be able to read that, but we have sea urchin, we have zebrafish, xenopus, cheek, corals, and so on. And you can see that gremlin has been conserved throughout evolution, and noggin at the bottom has also been conserved throughout evolution. So these two BMP inhibitors have been conserved. Now we wanted to find out their function in Hydra, and it was not easy to do that, of course, because it's very difficult to do genetics in Hydra. There are very few mutants because the cells are continuously renewed. But what we saw was that when we looked at the expression of noggin, as I told you earlier, it is expressed in the developing tentacles, as I showed you. For example, you can see these tentacles here. And in case of gremlin, it is expressed in the entire bud. So there is a difference in the expression of these two BMP inhibitors. Gremlin is expressed in the entire bud, while noggin is expressed at points where the tentacles will come up. So we did another experiment in Hydra, wherein we used an inhibitor of the GSK3 beta in this. So when we inhibit the enzyme GSK3 beta, the Wnt pathway goes up. You know, Wnt is one of the important pathways in normal development and carcinogenesis in humans, but it's important throughout the animal kingdom. So when Wnt pathway goes up in Hydra, it is responsible, actually Wnt is responsible for head formation in Hydra. And therefore, whenever you overexpress Wnt, you will see here in, look at capital figure D and then DCE, DCF, DEF, H. You can see that wherever the entire body of the hydra shows formation of tentacles. So because of this particular drug called alsterpolan, which is the DSK3 inhibitor, wind comes up and the whole hydra becomes a head and no part. So everywhere you can see tentacles. It's very beautiful here. So we then realized that hydra noggin is probably realized for the formation of tentacles. On the other hand, if you do the same experiment with gremlin, there are tentacles formed, but they do not express gremlin. So gremlin seems to be important in deciding the part of the body where buds develop. Noggin seems to be important, where the the tentacles develop. So those are the things that we found there. So in summary of this particular part, what we found out was, so BMP528 and cordin, these two genes have been were already reported by other labs, as you can see here. We have found noggin and gremlin, and when we see the expression of these, some of them were expressed. I mean, some of their expression is overlapping to each other. So we believe that noggin is important in tentacle patterning and gremlin is important in budding. And all these three, actually inhibit the BMP pathway. So along with others, we have a fairly good idea of how BMP pathway and BMP inhibitors work in hydra. Now we have to take it further to really find out whether it has a direct role in the formation of the nervous system. So these are the signaling molecules known so far. Actually, this is a 2020 paper, but I'm not aware of any new molecule being reported from hydra. So it has the Wnt signaling pathway, it has the FGF signaling pathway, BMP pathway, VEGF pathway, RTGase, and so on. And these are the 5 contributions that we have made, wherein we have found FGF also in hydra, about which I have not talked today. Then BMP pathway, we have found, noggin and gremlin. These arrows show what we have contributed. Then we have also found VEGF, which I will just mention because it's very interesting. And then we have also found some receptor tyrosine kinases from hydra. I will just mention VEGF for the following reason. See, VEGF, or the vascular endothelial growth factor, participates in formation of the blood vessels. It is important in angiogenesis. But when we talk about hydra, I told you that hydra is a diploblast. It doesn't have mesoderm, and blood is a mesodermal tissue. So hydra doesn't have any blood. But in spite of that, hydra shows the presence of VEGF. And when we inhibited VEGF signaling in hydra, I'm not showing the data today because there is not much time. I don't want to make it too technical. But when we inhibit VEGF signaling in hydra, tentacle formation is affected. So we believe that VEGF is important in branching of the tentacles. In higher organisms like us also, VEGF is important either in the formation of the blood vessels or the formation of the new nerves. So for branching processes, VEGF seems to be important. However, in hydra, it is used for a different purpose. In higher organisms, it is used for different purpose. So there are many such examples, and hydra gives you many such examples also, wherein a molecule is being used for a different purpose in less evolved animals and is being used for entirely different functions or additional functions in more complex organisms like the vertebrates, including human. So this is a very interesting aspect of how similar molecules, similar genes have been used again and again to carry out additional or entirely different functions. So we don't have to develop an entire set of genes again and again, but the same set of genes can be, modified a little bit and can be recruited to carry out different functions. And that's how, in spite of all this biodiversity, the developmental mechanisms that are at the core of development of all animals remain conserved. So from that point of view, from evo-devo point of view, working with hydra is very, very interesting and very rewarding. So these are the contributions, as I mentioned, from our lab. Sometime back, we also thought of providing hydra for teaching because many people had problems with using animals in teaching. And we have supplied this kit, which doesn't cost much. We have supplied it to many universities, colleges, research institutes across the country. And, people can establish a small hydra facility. They can use it for teaching. They can use it for short-term projects and so on. This is supplied by the Agarkar Research Institute. If any of you are interested in reading more details about this model system, the first article is from the journal Resonance, which is freely downloadable. Here I have given all the information that I talked about in simple words about Hydra, and also how you can maintain it and how you can use it for different kinds of projects. So some of the teachers may be interested in reading this article. And this is, as I said, freely downloadable, published by the Indian Academy of Sciences in Bangalore, Resonance. And if you want to read our review of our work about cell signaling molecules, this was also published in International Journal of Developmental Biology in 2020. So you can look it up. And for all our DNA repair work, which I have not talked about at all, but DNA repair is very important because DNA repair has implications not only in regeneration, but also the potential immortality of Hydra. You know that DNA damage plays a major role in cellular aging in our bodies. But DNA repair in Hydra is very, very robust. And this was published in Frontiers in Genetics in 2021, I think. And you can look that up. Yeah, 2021. And you can look that up also. Finally, just to acknowledge, this is Agarkar Research Institute in Pune. It's an institute, autonomous institute of Department of Science and Technology, Government of India. And our work has been funded by different funding agencies. And these are pictures of people who have worked. So most of them, as you say, are ladies. And so woman power has been a major force in our lab. There are, of course, a couple of boys also. But over the years, these people have contributed. I have not acknowledged them individually because this is more of a review talk for you. And generally, I would like to show that picture. So I think I'll stop here and take questions. I think I have maintained my time also.
Yeah, thank you very much, sir.
Now this house is open for questions and discussions. Anybody? If interested in asking question.
Sir, I am asking one question. Tyrosine kinase. You mentioned this tyrosine kinase receptor is present in Hydra. Sir?
Not tyrosine kinase enzyme, receptor tyrosine kinases. That means the receptors get, the tyrosine residues in the receptors get phosphorylated. So there are different kinds of receptor kinases in Hydra. And so I didn't mention tyrosine kinase per se, but obviously it is there because it phosphorylates the tyrosine residues. There are many kinases in Hydra.
So it may help in the vertebrates or human beings for some diseases, to cure some diseases. Or we can use as a model.
So we can't directly use any of the Hydra molecules, obviously, in the human beings, but we can use we can use the tricks of Hydra, for example, how they can regenerate. And if we know how they can do that, we can use them for organ regeneration in vitro or expansion of stem cells and so on. So that is precisely why people are interested in finding out how Hydra has this spectacular ability of regeneration. And not only Hydra, even planaria and amphibians and reptiles, or whoever is able to regenerate, we want to pick up those things from them because we are unable to regenerate most organs except for liver and maybe pancreas to some extent. And there are very specific reasons for that because regeneration always involves mitosis. And it can always go wrong and you can have tumor formation. So it's not easy to go in for reproduction. Regeneration, but we can certainly use some tricks from Hydra because the signaling molecules and the transcription factors are very similar to each other.
Oh, thank you, sir.
Very much, Dr. Surendra, for a very, very nice talk.
Thank you, madam.
Thank you.
Before you go ahead, I must apologize. I couldn't join yesterday and today. I'm in a meeting in Homi Bhabha Center in Mumbai. So I would have loved to listen to you also, but it was not possible. I'm so sorry.
No problem. But I just wanted to know if you have some information about how many species of Hydra are found in India and from which part of a water body do you exactly collect Hydra in nature?
Okay. So India, at least so far, only two species have been reported widely. One is the brown hydra, Hydra vulgaris, and the other is the green hydra. And these are found almost everywhere in India. So there was a monograph published by the Zoological Survey of India sometime in the late 70s by a scientist called Professor Shivtosh Mukherjee, who was at JNU. And he has seen most of the big cities, and you practically get it everywhere in India, practically everywhere. If you go outside in Raipur at lower temperature, I'm sure I can find some hydra in the clean ponds that you have around. Yes.
I have also one question.
I can't hear you, sir.
When we culture hydra, I think hydra viridis. I'm not.
We are losing you, sir. I can't hear you continuously.
Okay, can you hear me now? When we culture hydra, it is possibly hydra viridis. I have noticed sometimes 5 tentacles, 5, sometimes 6, sometimes 7. The same individual. I think it is login related mechanism.
We don't know that, but we have done a very careful analysis of number of tentacles in a given species, and it's published also in Current Science. Maybe if we communicate with each other by email, I can send you some reprints. So what we see is this is very natural variation that we see. But I am at this stage, I am not comfortable enough to comment on the role of noggin there, because this seems to be very natural variation. So you get tentacles right from 5 to 8. And we have actually counted some few hundred hydra and shown the distribution of those tentacles. So it's a very natural variation that you see.
Okay. Thank you.
Welcome. We have also done some work on use of hydra in, looking at toxicity and all that in collaboration with Professor Akbar Shah. And that's also a very important model for that. But my basic interest has been in fundamental biology. So I only mentioned that today.
Okay. We actually use Cereodaphnia and Daphnia as a prey for.
Right. Absolutely. Yeah. Any other questions?
Good afternoon, sir.
Good afternoon.
I want to know, sir, which type of regeneration is found in hydra?
Oh, okay. So that I didn't mention for want of time. So there are two main kinds of regeneration in animals, and in hydra it is known as morphallaxis. Because in case of hydra, the initial stages of regeneration do not need cell proliferation. So what happens is, if you take a small piece of hydra, you get a small hydra regenerate. It has to eat to become a normal size. Initially, it doesn't require growth, and therefore it is known as morphallaxis. This is very different from the regeneration that you see in amphibians and lizards, tail or limb regeneration, wherein it is known as epimorphosis, where for example, if I'm an amphibian and if you cut my limb, please imagine, don't do anything to me. If you cut my hand here, then the cells here are already differentiated cells. So they cannot undergo mitosis. So they have to undergo de-differentiation first. And after that, they will undergo proliferation. And those newly formed cells will then undergo differentiation and form the remaining limb. All this is not happening in hydra. In hydra, it is only two-stage process. One is wound healing, which is common to all regeneration. And the second is formation of the new tissue. In higher organisms or in lizards, it is 4 stages. So first you have wound healing, followed by de-differentiation. The next stage is blastema formation, and finally cell differentiation. So regeneration in more complex organisms is obviously also very, very complex. And in planaria, you have only 3 stages. You have blastema formation, but no de-differentiation. So, along with the complexity of the body, the regenerative capacity also has become less and less and more complex. And in fact, we have almost lost it completely.
Okay, thank you, sir, for this information.
Thank you.
Any more questions? Okay. In that case, I invite Dr. Shashi Gupta, Assistant Professor, Government Nagarjuna PG College, to please give vote of thanks to Dr. Surendra.
Thank you, Oja madam. Are you able to hear me?
Yes,
Yes,
please.
ma'am.
Okay. On behalf of all the members of Government Nagarjuna PG College of Science, our research scholars, and all the participants, I extend a really hearty vote of thanks to our eminent speaker, Dr. Suren Ghas Kadbi. Today we had a golden opportunity to hear you, sir, and your wonderful information. It was very informative lecture and interesting research findings, and this will be surely very helpful for further research. The slides on signaling pathway in Hydra was very interesting and very informative. I extend my gratitude to you, sir. Thank you so much for sharing
Thank
your
you.
findings. Thank you,
Thank
sir.
you. My pleasure. My pleasure.
Thank you, ma'am. Thank you, sir. Now, we proceed to next part of our session. These 2 days have brought together intellectual mind and lots of information and knowledge regarding planktons, and hope this webinar will help building confidence of researchers and academicians to work further in following line. Now, I invite Dr. Kavita Das, Organizing Secretary of webinar, to please present summary of this webinar of last 2 days.
Thank you very much, Gunjan.
Thank you, ma'am.
Now we have reached the end of our international webinar, and it is my task to provide some closing remarks. I, Dr. Kavita Das, Organizing Secretary of this webinar, first and foremost, I would like to express my appreciation to the speakers and the panelists for their valuable contribution in this international webinar on plankton biology. On this session, we are going to, we are in the Diamond Jubilee year of our college. So it is a
I
very
see.
great to organize this webinar, and you all are present with us in this Golden Jubilee year. Presence and engagement of participation plays a pivotal role in the success of the webinar. Thanks to all of you for your active participation, the provoking question and valuable discussion, emphasizing that your collective presence contribute to the vibrant and intellectually stimulated atmosphere of the event. It is a great pleasure to hear with all of you. I would like to extend my heartiest congratulations to entire team who had made this event a huge success. I also would like to comment and send the deepest gratitude to everyone who took personal and professional time to attend this webinar. I just summarize this webinar. Our session is started on first day. Our session is started with the encouraging word of our principal, sir. And our first keynote address speakers are Dr. S.S. Sharma and Dr. Nandini Sharma from National Autonomous University of Mexico. Their first talk is Basic Biology of Rotifers, Cladocerans, and Copypods with emphasis on species. This is delivered by the Dr. S.S. Sharma. He elaborated and explained the types of species, parthenogenetic reproduction, difference between the male and female, and many other aspects of this species. Second part of keynote lecture was delivered by the Dr. Nandini Sharma. She focused on the application part of these animals. Then second, our lecture is ecotoxicology with emphasis on xenobiotics and cyanotoxins. This is delivered by the Dr. S.S. Sharma. As we know, the cyanobacteria are blue-green algae and primitive group of oxygen photosynthetic bacteria. He emphasized that cyanobacteria blooms can adversely affect our water quality, including increased turbidity, hypoxia, anoxia, and production of unpleasant odor and taste. Cyanobacterial blooms are also a potential health hazard due to the ability of some species to produce toxins. So ecotoxicology is a multidisciplinary field and integrates toxicology and ecology. This is emphasized by the Dr. S.S. Sharma. And then next lecture is by Dr. Nandini Sharma on the large scale phyto and zooplankton cultures. This phase, he emphasized on the growth of algal culture, different media he introduced and their composition, how to culture the plankton for the fish culture conditions, how can we vary in the outdoor ponds and in the laboratory ponds, and added promote a bloom of natural microalgae, microcultures, how rare the indoor under the control environmental condition. He also explained us there is no need of costly equipment. We can just use pickle and jam bottles for the culture of. So these are our eminent speakers of our first day. And our second day started with the guest lecture of Dr. Vimal Kanungo, Assistant Professor of Botany from the JY Chhattisgarh College, Raipur, and his lectures on the phytoplankton in some ponds of Raipur city. He very well explained the biodiversity of planktons found in the three major ponds of Raipur, like Maharaj Band, Buda Talab, and Kurbeda Talab, or impact of man activities on these ponds and their how, and also alarm to us that adding municipal waste destroying our natural ponds by converting it into the eutrophic lake. So it is a good lecture. We all know about, he discussed about the biodiversity of planktons of Raipur, Chhattisgarh. Then next lecture is followed by the Dr. Nandini Sharma on design of simple predation experiment to improve survival of larval fish. So it is a good lecture. And if you want to start a fish culture as a startup, you have to listen this valuable lecture of Madam, because plankton will be used as a food for survival of fish culture. Good feeding behavior, factor he delivered with the good feeding behavior, factor affecting food preference, reaction distance, level of hunger, because preference depends on the level of hunger. So all the aspects you have to develop for the fish culture pond, he discussed all aspects in very briefly. So these are the very good lectures by the Dr. Nandini Sharma if we want to culture fish or we want to start up the fish culture. And then this is followed by the analysis of water quality using zooplankton indicators and water quality indices by the Dr. S.S. Sharma. So Dr. Sharma emphasized that the rotifers, we can use rotifers as the bioindicators. Rotifers are indicators of habitat. Direct indicators of trophic level. We can identify the trophic level with the rotifers. In trophic level, you find different planktons. Planktons are also stress sensitive according to pressure. Presence of there, you can classify lake as oligotrophic, eutrophic, mesotrophic. So they can very useful for the pollution indicators. So these all lectures are very good and very emphasis for our knowledge. And then our next lecture is started with the water quality and planktons by Dr. M.L. Nayak. Sir emphasized that the planktons of Chhattisgarh or importance of planktons for Chhattisgarh, because Chhattisgarh is a state of pond. There are so many ponds in Chhattisgarh, and now we are losing these ponds due to the human activities. He detected the presence of coliforms in pond, in drinking water also, and alarm us that unhygiene condition of ponds village pupils are using this water for drinking. He also emphasized that sulfur-rich water of tala pani, and it is a good for researchers, important for researchers. He told that the new researchers can do this sulfur-rich water and tala pani, and then found some new aspects of planktons. He also emphasized the urban ponds are now more contaminated than the village ponds. So it is a alarming for us. And with this, he also identified the more than 50 species of Euglena in Chhattisgarh ponds. And with Nandini Sharma ma'am add a good suggestion for us. He give for this social awareness, add researchers, our young researchers for social work for the awareness in the villages. So we can calculate our ponds condition, we can reform our pond conditions. Thank you very much, ma'am, for suggesting that this is a good suggestion from your side. And this is followed by the Dr. Suren Ghaskar-Bissa's lectures, Hydra as a model system of a study to study evolution of cell-to-cell signaling. It is a very good lecture from the Dr. Sir. It shows this, and the Hydra is a monster in mythology, but it is the first organisms who has nerves. And the first, he also emphasized that first regeneration experiment was started from 1740. And also emphasized that Hydra is the simplest organisms. And first division of labor started in Hydra. Just a minute. Just. And he also emphasized the similarity between the xenopus and Hydra. Amino acid sequence shows the structural relevance from Hydra to human. Comparative analysis of Hydra noggin, similar to human noggin. And there's injected Hydra noggin in mRNA to xenopus and found it helped in the rescue the xenopus. It is a good findings, I think. And new molecular gremlin is also identified him. And he also that expressed the entire body BMPF at 8B genes is tentacle initiation. There are so many molecular experiments done by the Dr. Surendra, and it is a good work, sir. And signaling pathway of Hydra. So we can use Hydra as a model for the regeneration of in our body. So this is the, I think we are so many good lectures, and it is our privilege that we have all these eminent speakers with us in this our international seminar of plankton biology. So a dream does not become a reality through magic. It takes sweat, determination, and hard works. So this conference has taken its shape by the hard work and determination of my fellow colleagues, of my department, office staff, and all the team of organizing committee, and support of our college staff and guidance of our principal, sir. Thank you all from my side for making this webinar as successful. I conclude with that of D.R.D. Tata. All of us do not have equal talent. All of us do not have equal talent, yet all of us have an equal opportunity to develop our talents. So become like a bird, expand your wings, learn new things, and fly as you can. Thank you very much from all of you.
Thank you, ma'am. Now, moving forward, I think this webinar has added values to our knowledge, which would enhance level of education further. I would like to know how well our efforts resonated with all the members who have joined this seminar. I request participants to please share their feedback. Participants, you are most welcome to share your feedback.
Hello.
Yeah, to everyone. This is Akansha Chandaka.
Akansha, please come closer. Your voice is not clear.
Ma'am, now it is audible?
Yes.
I'm a research scholar at Science College, Raipur. I'm very glad that I got to attend this session. Thank you so much to all the professor and organizer of this webinar. Thank you so much for inviting us. Thank you.
Thank you, Akanksha. Anybody else?
I
should move now.
Okay.
Moving forward, I invite Dr. Renu Maheshwari, Professor, Zoology Department, Government Nagarjuna PG College of Science, to please present vote of thanks.
Thank you, Gunjan.
Just a minute, ma'am. I can add something. Our principal sir is busy in a meeting, so he is not attending this valedictory function.
Yes, ma'am.
Announced.
Okay. Thank you. Thank you very much, Gunjan. Good afternoon to all. It has been such an honor to be a part of this wonderful event, to listening many eminent speakers. On behalf of the Department of Zoology and NPG College of Science, Raipur, I convey my regards and hearty thanks to our honorable keynote speakers, Dr. S.S.S. Sarma and Dr. Nandini Sarma from Aquatic Zoology Laboratory, Research and Postgraduate Division, National Autonomous University of Mexico, who gave the opportunity for the organizing this memorable webinar. Thank you, sir. Thank you, madam. I would like to extend my heartfelt gratitude to our esteemed guest, Dr. Amal Nayak, member of Biodiversity Board of Chhattisgarh State, and our guru, who accepted the invitation for this event. Thank you very much, sir. I would like to thank our colleague, Dr. Vimal Kanungo from Government Yoganandam Postgraduate Chhattisgarh College, Raipur, who accepted our invitation for the part of this international webinar. My special thanks to Dr. Suren Gaskadbi, who is the member of Maharashtra Association for Cultivation of Sciences from Agarkar Research Institute, Pune, Maharashtra, who has accepted our invitation in a very brief time period and only in one telephonic call, and gave us his precious time from his busy schedule. Thank you very much, sir, for your cooperation. My sincere thanks to our principal, Professor P.C. Chaubey, patron of this national seminar, for his constant support and encouragement throughout this event, and that radiated a source of energy within us. I would like to thank our beloved head of the department, Professor Seema Gupta, and convener of this event, for her constant help. I am very much thankful to our beloved organizing secretary, Dr. Kavita Das, for her dedication. We have been fortunate enough to be backed by a team of very motivated and dedicated organizing committee, faculty colleagues, and non-teaching staff members who always stand by us and to take on the completion of tasks beyond their comfort zones. I am thankful to all the dignitaries from different places for making this webinar successful through their participation by joining either Zoom platform or via YouTube. I would like to extend my heartfelt thanks to all of you present here for making time to be with us. I would like to thank all of them who directly or indirectly associated with us for this event. Last but not least, a very special and big thank to Mr. Ronak, a student of class 9 and son of Dr. Kavita Das, organizing secretary of this webinar. Without him, this event was not possible. From purchasing to Zoom, platform, generating link, and online live streaming on YouTube, all of these were arranged by him. Thanks a lot,
I'm
Ronak.
calling him.
And
Just a minute, I am calling him.
हाँ, उसको बहुत
Just
बड़ा
calling him.
Yeah. मैं एक बात शेयर करना चाहूंगी यहाँ पर कि हम लोगों ने ये तय किया कि हमको जूम प्लेटफॉर्म पर ये कार्यक्रम कराना है। तो ऐसे समय पे ये हुआ कि हमने जिस ऑनलाइन हमारे जो वेंडर थे उनसे बात की, तो उन्होंने कहा वी आर सो बिजी, तो आप लोग खुद परचेस कर लें। तो ऐसी स्थिति में हमें ऐसा लगा कि हम किस तरीके से ये सारा काम करेंगे। तो रौनक, हाय रौनक।
Hello.
Hello. He's a man behind this event. ये बच्चा जो मेहनत करके हम लोग को पूरा तैयारी कराया है और पूरी हम लोग को मतलब प्रैक्टिस कराया कि किस तरीके से हमको इस इवेंट को सक्सेसफुल बनाना है, इसका श्रेय पूरा रौनक को जाता है। सो वेरी बिग थैंक टू रौनक।
Thanks, Wasi.
Thank you. It is, if time is money, then today you have spent million for this event. Once again, thanks to all of you for making this international webinar on plankton biology successful. Wish you all
Thank you, madam.
a safe
Thank you very
and
much.
healthy life. Thank you. Thank you to all.
Thank you very much.
Thank you, ma'am.
Ma'am.
Thank you.
It's your
Thank you,
initiative.
everyone.
Sarma madam and sir.
And it's your initiative. We can.
Yeah, yes, yes, it's your initiative. Because of that, we do this.
This happened because of you.
Yes.
Thank you very much. And I will discuss with all your coursework and then MOU about your MOU with our principal sir and let you know with your email addresses and the WhatsApp. Thank you very much. Ma'am, you are invited in our college.
Yes.
Please come.
Yeah. हाँ, one more thing. सोमना, आप लंदन से जुड़ी, इसके लिए आपको बहुत बहुत धन्यवाद। और चूंकि पार्ट ऑफ रायपुर मतलब तुम RSU की हो और इन लोग के साथ की हो, तो शायद मैंने बहुत नाम तो तुम्हारा सुना था, लेकिन देखने का मौका पहली बार मिला। थैंक यू वेरी मच।
हम लोग साथ में पढ़े हुए हैं। MSc we have done from this life science. We are a student of NIAC, sir. Thank you very much, sir.
Thank you.
Thank you.
Thank you, everyone. Have a wonderful times ahead. Until we meet again, be happy and stay safe.
Thank you, ma'am.
Thank you, Sumna.
मैम सब लोग जितने पार्टिसिपेंट्स है प्लीज अपना कैमरा चालू कर दीजिए
वीडियो ओपन करें
so
तो हम
that
लोग
we
एक
can
पिक्चर ले। ओके, थैंक यू गुंजन, दिस इज फॉर सजेशन फॉर थैंक यू वेरी मच। All participants can open your video, please. Please, all of you, please open your window. अभी मैं जितने आ रहे हैं उतना लेके जाती हूँ। मैम, प्लीज विजिट आवर कॉलेज। You are not. Thank you very much, ma'am. It's you. Okay. I will send all the photographs and then certificates to. Okay.
Thank you, ma'am.
Thank you very much. Thank you.
Thanks a lot, ma'am.
Thank you so much, ma'am. Thank you so much.
Bye-bye.
Thank you. Okay, now I am leaving the session. Thank you all of you for joining us and making this successful this webinar. Thank you. Hello, Sumna. Thank you very much for your interest in our webinar.
Thank you. Learned a lot. Learned a lot.
Yeah.
And now I'm growing interest in doing, I want to go back to research.
Okay, come join us.
Okay.
Okay, bye. मैम मैं एंड करूं मीटिंग? माहेश्वरी मैम?
हाँ कर दो अब, और क्या। गुप्ता मैडम तो अभी दिख नहीं रही, कर दो ले।
है ना?
ओके।
मैम दिख नहीं रही है।
हाँ
सुनीता पात्रा जी दिख रही हैं।
हाँ, हमने फोटो खींच ली उनकी।
हाँ,
इंदु की भी
इंदु
आगे।
दीदी दिख रही हैं। रुक
हाँ।
जाओ।
हाँ तो रुक जाओ भी एक बार। और कौन कौन आ
और
रहे
हम लोग सब कोई रुको, सुनना 2 मिनट।
अजय ना
कोई
मैम,
हमारे
starting में
ऑर्गेनाइजिंग कमेटी कम से कम सब अपना वीडियो ऑन करें।
सतीश, सीमा
एक जगह
गुप्ता
आ सकते हैं,
मैडम,
सब इकट्ठे हो जाए, सब आ जाओ एक जगह।
पल्लवी, शशि ज्वाइन करो और वीडियो ऑन करो।
बाहर चलेंगे
संगीता मैडम, संगीता मैडम नहीं है।
गैलरी में।
सुनीता, संगीता मैडम को बुला लो।
Sunita, can you hear me?
अभी नहीं है।
अच्छा।
yes, I can hear Minna.
How are you?
फिर कैसे हो गया, कम कैसे हो गया?
अब फिर मैं रौनक को बुलाने जा रही हूँ, तेजस को, कि मुझे जो है ये स्लाइड में नहीं आ रहा है, व्यू में आ जाती है। देखो
Hello, Sumanna.
गैलरी। यस,
Hello.
अब आया ठीक।
Hi.
Hi. Hi. I'm in the department. Yes.
Yes. I am now
It was nice seeing you.
almost it's morning, 4:30
It's
a.m.
almost morning, I think, है ना? 6 morning.
प्रीति मिश्रा कहाँ
4:30.
रह गई?
So waited all night. All night to
Shashi ma'am,
be a part of this webinar.
Of knowledge and very interesting topics. And I really thank Kavita for giving me this opportunity and sharing the link.
Thank you. And it is also you are interested and listening.
I found a PT provider, proficiency testing provider, and I have sent you the link.
Okay.
And they are actually international phytoplankton group.
Okay.
And they provide unknown samples to and they give certification also to check, to ensure the competency of the phytoplanktonologists, to ensure that they are competent.
Good.
I have shared the link in our WhatsApp group, International Webinar, so you can check.
Okay.
Check that and you can contact them.
Okay, thank you very much for information. Thank you. Satish and Shashi Gupta ma'am and Sangeeta ma'am.
शशि मैडम क्यों नहीं जुड़ पा रही, नहीं मालूम।
Sangeeta is not there.
Okay. So इतनी फोटो तो हम लोग ले ही लेते हैं जितने हैं।
इतनी तो मैं ले चुकी हूँ, और ले लो एक बार। अभी कहाँ ये सतीश नहीं है। शशि मेरे साथ इधर ही साथ में ज्वाइन कर लो, इधर आ जाओ। हाँ तो वो चेयर लेके फटाफट आ जाओ।
Next time I visit Raipur, I will definitely visit your.
पल्लवी कहाँ चली गई है? पल्लवी नहीं है।
पल्लवी और मैम एक साथ।
अच्छा, तो थोड़ा अगर फोन पे हो तो थोड़ा आड़ा रखो,
आगे पीछे हो जाइए थोड़ा सा।
मैम एक्चुअली साथ में है।
गुड।
नहीं
आड़ा साथ में।
हाँ अब ठीक है।
कांग्रेचुलेशन मैम, गुप्ता मैम।
इधर मेरे और इधर सर मेरे तरफ सर।
सुनीता आप सीधे
और
हो
इधर
जाइए।
वो करूंगी तो वो हो जाएगा।
आपका भी
रुको,
दिख रहा। हाँ ऐसे हो जाओ, ऐसे
पीछे से
गुप्ता मैडम कांग्रेचुलेशन।
अब मैं फोटो नहीं खींच पाऊंगी। अब कौन बच गया?
आप दीदी आप आनी, प्रीति मिश्रा मैम।
सतीश कहाँ रह गया है? सतीश
प्रीति मिश्रा मैम, हाँ
इसमें
थोड़ा सा
तुम
ऐसे
लोग
adjust
आड़ा
कर
आड़ा
लो।
हो, प्रीति और आपकी फ्रेम ऐसी कर लो, पल्लवी और प्रीति
दिख रहे हैं क्या?
वर्टिकल नहीं, हाँ दिख रहे हो, हॉरिजॉन्टल करो, वर्टिकल मत करो।
हॉरिजॉन्टल जैसे मैं और रेणु दीदी हैं।
दिख रही है।
अच्छा तो वर्टिकल कर लो, तो तुम्हारा हॉरिजॉन्टल में आड़ा ही आ रहा है, तो वर्टिकल कर लो।
ममता दास, यू कैन ओपन योर वीडियो।
हाँ
मधुलिका, ममता, जागृति, साहू, जो भी हैं, आप अपना वीडियो ओपन कर सकते हैं। ओके, इतना तो हम ले लें। एक मिनट, मैं सेव कर लेती हूँ पहले।
वो कर लेना क्या, जियो टैग। जियो टैग,
जियो टैग तो सब फोटो जियो टैग ही है।
नो, आई एम नॉट टेकिंग जियो टैग, मैं जस्ट नॉर्मली
हाँ मैंने सारी जियो टैग ली है
स्क्रीन
इसलिए
कर रही हूँ।
सुनीता आप चलो मत, अब आप खड़ी हो जाओ, नहीं तो फोटो
ये ना
नहीं आएगी
बाहर
तुम्हारी।
नेचर के साथ खिंचाने आएंगे।
नहीं वो ठीक है, पर अब थोड़ा स्थिर हो जाओ।
स्थिर हो जा। हाँ
हाँ
यस, ओके,
थैंक यू, थैंक यू।
Okay, bye, bye everyone.
बाय 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 बाय।
बाय सुमना, नेचर के साथ नहीं, कनेक्टिविटी के साथ।
अच्छा फोटो में फोटो अच्छी दिखी है, ठीक है चलो, ओके चलो बाय। चल लिफ्ट कर दो कविता।
बाय, आई एम लीविंग।
कॉन्ग्रेचुलेशन टू ऑल टीम
फॉर यस, चलो ठीक है, कॉन्ग्रेचुलेशन टू रौनक।
Everyone.
एवरीवन है, पर वो रौनक नहीं होता तो हम लोग अभी होते रहते।
Well done.
ओके ओके बाय।
मेरा नहीं हो रहा था ज्वाइन, पता है।
लीव कर दो, लीव कर दो कविता।
हाँ मैं कर रही हूँ दी, मेरे को फ्रॉम ऑल नहीं दिख रहा है, इसलिए मुझे रौनक को ही बुलाना पड़ेगा।
हाँ
तेजस प्लीज कम।
चलो निफ्टी कॉन्फ्रेंस, अब नहीं जाती मैं कॉलेज, मैं साइन करके
अब कौन करना, जाना बस हो गया।
ये मीटिंग वो अपनी तरफ